Sen, currently serving as Deputy Director General of GSI SU Maharashtra, whose influential research on Deccan flat basalts, mafic dikes, and continental volcanism continues to shape our scientific perspective on large igneous provinces. Please welcome Dr. Shekhawat and Dr. Sen to their seats. We are also honored to have ex-DDG Garkhal Sahab among us. Ex-DG Garkhal Sahab among us. May I now request Dr. Praveen K.R., Director of GSI CHQ Kolkata, as our rapporteur to record the proceedings of this session. In the spirit of scientific celebration, it is my privilege to welcome you to the technical session. This session brings together perspectives on how the Earth's lithosphere evolves from the mesoscopic to the nanoscale and from ancient cratons to the active Himalayas. We look forward to an engaging and stimulating session, and it is now my honor to introduce our keynote speaker, Professor Manish Mamtani, who is a professor of geology at Department of Earth Sciences, IIT Kharagpur. Professor Mamtani's research spans structural geology and microtectonics with over 80 publications, addressing fabric development in deformed rocks, deformation mechanisms, and the structural controls on mineralization. At IIT Kharagpur, he has established a state-of-the-art fabric analysis laboratory equipped with AMS measurement, microstructural characterization, SEM EBSD work, and TEM studies, enabling integrated investigations from field scale to nanoscale. And his contributions have been widely recognized. He's a DAD fellow, a Humboldt Research Fellow, and has served as a visiting professor at the University of Turin. Among his honors are K. Naha Award for Structural Geology and the National Geoscience Award from the Government of India. Professor Mamtani currently serves as the president of the International Association for Structural Geology and Tectonics and sits on the board of European Society of Deformation Mechanisms, Rheology and Tectonics. He has also served as vice chair of the IOGS Commission on Tectonics and Structural Geology and is a member of the advisory editorial board of Journal of Structural Geology. Today, he will be delivering the keynote address of this session, Structural Geology from the Mesoscopic to Nanoscale, integrating field AMS, SEM, EBSD, and TEM studies. Please welcome Professor Manish Mamtani.
Okay. Okay. So, thank you very much for a very elaborate introduction. And indeed, it is an honor for me to be presenting this talk, which is entitled Structural Geology from let me just switch on the pointer option. Okay. Structural geology from the mesoscopic to the nanoscale, integrating field AMS, SEM, and EBSD TEM studies. When I gave this proposal to Bashap, who actually contacted me to give a topic, I was a bit worried whether I will be able to do justice to this in the designated time of 15-20 minutes, but I'll try my best. It's an honor to make this presentation as Geological Survey of India celebrates its 175 years of existence, and it's an interesting coincidence that IIT Kharagpur celebrates 75 years of its existence. Since the topic deals with the transmission electron microscopy, I dedicate this talk to Dilip Saha, who is no more with us. I had correspondence with him about TEM when I was a student doing PhD in MS University, Baroda. So this talk is in his memory. This is slide number 1, class number 1 of my structural geology course in IIT Kharagpur, where I impress upon the students that structural geology is a game of scales. So what most of us do is we go to the field, we identify a problem and then collect samples. We do a lot of microstructural studies, understand the time relation between crystallization and deformation, microprobe, fluid inclusions, PT paths. This is what almost everybody doing something with structural geology is doing. Then we try to relate all this to some supercontinent assembly and then to global scale tectonics. So this is the entire cycle that a lot of people working on structural geology and tectonics, they focus on. And somewhere with the advent of technology at the micro scale and nano scale, we are able to do transmission electron microscopy and SEM EBSD studies. And there is now a possibility to look at oriented sections of samples, of geological samples at different scales, and identify, microstructures as well as nanostructures. So we are all working, with field work at the base, at the core of everything, and then meso, mega, meso, macro, micro, nano around it. Okay, so if I was to prepare a triangular diagram with mega, meso at one end, micro at another, and nano at, one corner. So most of the studies in the world, they deal with this, right-hand part where we combine mega, meso, and microstructures, and the nanostructure part where we would like to link the microstructure and field structures with the atomistic scale processes and structures. This is, weak globally, and that is why this multi-scale, analysis from meso to nanoscale using these different techniques comes into picture. So those who, and a lot of us do structural geology investigations, and we know that the microstructural studies and field studies, they involve a lot of kinematic analysis, and kinematic analysis requires a reference frame, which is commonly the XZ section of the strain ellipsoid, which is the section that is parallel to the stretching lineation and perpendicular to the foliation. I am born in 1970, so, and my father is born before the World War II. I forget the year exactly, maybe 1939. So in 1930, that is before the birth of my father, Bruno Sander wrote his text in German, which was then translated into English, an introduction to the study of fabrics of geological bodies, and that is the year of my birth. And he, at that time, identified AC plane as being important in tectonic studies. And by the time I took up geology, BSc, etc., from that time onwards, we know that the XZ section, which is the section parallel to the stretching lineation and perpendicular to the foliation, is very important. And all these structures, mica fish, SC fabrics that we see in textbooks, this has to be seen in the XZ section. And as is listed in one of Pashkier's textbooks, Pashkier et al. 1990, it is mentioned that if you don't have stretching lineations in a rock, then it is almost impossible to identify the kinematic, reference frame, and because you don't know where is the x-axis of the strain ellipsoid. So as you can see, I am lying down on a rock. It's just suggestive that, we are always hunting for stretching lineations. So that is the XZ section in which we want to do kinematic studies. So this is the kinematic reference frame in the field where the rock has stretching lineation here, and the rock, of course, has a foliation, and you can make a rock slice parallel to the stretching lineation, perpendicular to the foliation, and then make a thin section. Don't forget that depends how you mount the sample on the glass slide. So the sense of shear here is top towards 330. If you mount the sample reverse on a slide, then still the sense of shear remains top to the 330 degrees. But if you don't have a stretching lineation, then this is an example from a cafe which had a beautiful spoon in Turin. This is a picture of 2019. So if you have two spoons, apparently it appears this is dextral shearing and that is also dextral shearing. But if you don't know where is the x direction, you don't know where is xz, then you don't know where is the top towards what direction sense of shear. So in this situation, how do you determine the xz section? So as Mahatma Gandhi said, forces of nature act in a mysterious manner. We can but solve the mystery by deducing the unknown result from the known results of similar events. So the unknown is the xz section, and the known could be identified, or recognized with the help of AMS studies. So you take a field-oriented sample, then do AMS analysis of that, identify the three principal axes of the AMS ellipsoid, and identify K1, K2, K3 axes of the AMS ellipsoid. These would be equivalent to X, Y, and Z of the strain ellipsoid. And we have plenty of examples where we are able to prove that the K1, K3 section of the AMS ellipsoid is equivalent to XZ of the strain ellipsoid. As a case study, this is a sample of graphite-bearing schist, quartzite from Naxos in Greece. This sample has a stretching lineation and it also has a foliation. So we really don't need to do AMS in this because the XZ section can be identified from field fabric. But we wanted to see that whether it is true that the sample must give us X, Y, Z equal to K1, K2, K3 in a sample where you have a stretching lineation and foliation. So this is the pole to the field foliation, pole to the magnetic, stretching lineation, magnetic lineation. So you see they are similar. So this means that AMS works in this sample. And then when you do EBSD studies, you can get very nice crystallographic preferred orientation of quartz. Now, what happens if I extrapolate this same logic to a rock which does not contain a stretching lineation? So we analyze a peninsular gneiss sample from the Dharwar region. This sample has a foliation, but it does not have a stretching lineation. When you do AMS, you are able to identify the magnetic lineation, which is K1. You are able to get the pole to the magnetic foliation, which is K3. And then if you see, the field foliation pole is having similar orientation. So it means that this magnetic lineation, K1, I can treat as equivalent to X direction of the strain ellipsoid. And if I do that, and I make a thin section, which is parallel to the K1, K3 plane of the AMS ellipsoid, under the logic that this is same as or equivalent to XZ of the strain ellipsoid, then I get very nice quartz CPO patterns, crystallographic preferred orientation of quartz, which in this sample gives me a top towards 325 degree sense of shear, which fits in the regional, tectonic fabric of the rock. So this is the certain things that I have been focusing on for almost 20 years, more than 20 years of my career. But then starts, you have to keep rediscovering yourself, that how do you remain relevant in science? So the idea was now to look at the structures at the nanoscale. And this is a very challenging exercise because you need to do SEM EBSD studies in a kinematic reference frame, which is fine. You can identify the region of interest for doing TEM studies, that is also fine. But then you need to excavate the thin film from this thin section. And that is a very, very challenging process which we are still not able to do in India as of now. So there are two possibilities. One is to excavate a thin film which is perpendicular to the plane of view. So if this is my thin section, I can excavate a thin film like that, and which is this example. And then there is another example to the right, which is in plane excavation. So if this is the thin section, then I need to scoop out a thin film parallel to the plane of view. And then we, do the TEM studies in these thin films. So these two back-to-back studies were actually supported by the DAAD, this one, and that one was supported by the Humboldt Foundation. So I will just skip through this slide very quickly because it's a very elaborate process. There is one part which is successfully carried out in IIT Kharagpur, which is to the left, which is SEM study of magnetite. And magnetite I chose because I'm giving you this example because that is all I have. And the deformation mechanism of magnetite is another issue which is a challenge, and I was addressing some of those issues in my research. But right now we just focus on the methodology. So we can do this part in IIT Kharagpur, and then the thin film excavation and the TEM investigation. This was done in Karlsruhe Institute of Technology in Germany. You see, in India, we can do TEM studies of metals. People are doing it in IIT Kharagpur, in IISc Bangalore, other IITs. We can't do it on rocks because you just can't make a thin film from a rock. It's very challenging. Plus, the most important thing for me as a structural geologist is that I need to keep a track of the reference frame. So when I have a rock thin section, I know where is the geographical north, what is its field orientation, or where is the x direction of the strain ellipsoid. Now, in metals, they are not worried about this. But in structural geology, I want to think about how I can relate the nanostructure to this, tectonic reference frame as well as the geographical reference frame. So this was a sample which was taken from the Slipsecond region in Sweden. It has a top to the northwest sense of shear, green schist facies, elongated magnetite grains. So we are able to do EBSD of magnetite, and we can identify an area where we want to do detailed EBSD analysis, and then do the misorientation maps to identify where in the thin section there is a strong change or weak change in the crystallographic orientation of the magnetite crystallography orientations. So there is a low angle grain boundary where there is a misorientation of around 6 degrees. There is a high angle grain boundary where there is a misorientation of around 26 degrees. And this 1, 2, and 3, 4, these are the regions of interest that were identified by me in IIT Kharagpur. All these images are from IIT Kharagpur. And this is where we wanted to excavate the thin film. So now we go to the Fib lamella, that is focused ion beam method is used to excavate the thin film. So you see, very important thing is that the Fib lamella, the focused ion beam excavation under SEM will be done by a specialist who knows to use that machine. The transmission electron microscopy will also be done by a material scientist who knows how to use the machine. They don't know geology. What do I do? You know, as the person who is leading this research, this is what I do actually, that I put the entire, you see, thing in the block diagram, in the tectonic reference frame, so that I know exactly now how my thin film, when it is excavated, where are the orientations. That is my job. So this is a cheese and knife example, which is an analogy that you can either slice it like this and remove it like that, plane normal, or in plane, that is, you slice it parallel. So this is just to highlight the sophistication of the process, that you know, are keeping track of the direction, because the sense of shear is top to the northwest. So when the thin film is excavated, we should be able to keep track of this northwest, where it is. So we keep a track of that, then it is mounted on the TEM grid, and after that, you know now how it is. So the smooth side is northwest and the rough side is southeast. And this roughness is left purposefully, so that, because once the thin film is 50 nanometers, you know, once it goes into the TEM, they rotate the thin film, you don't know where is what. So this you need to keep track at every stage. Then it is thinned, you slice it further, and now you are ready for TEM analysis, that is this. And then the orientation of this thin film, you know in the reference frame. Okay, so this is northwest, this is one lamella, this is another lamella, and these are excavated across the grain boundary, low angle and high angle, in this reference frame. So then the TEM studies are done, which is again another very sophisticated exercise, which I cannot do. It is the material scientist who does, but we are able to identify stacking faults, dislocations, and various other nanostructures, Moir fringes, which I'll show you like that. So at the low angle grain boundary, you have translational Moir fringes, which are actually fringes that develop when the crystal lattice of two subgrain boundaries, they overlap each other. So you have translational, you have rotational at the high angle grain boundary. And when you put this in the tectonic reference frame, the sense of shear, it fits in the nanoscale with the regional top to the northwest sense of shear. And that is what I actually defined in my work as nanotectonics in geosciences. So this was published 5 years back. Then the last example, before the chair rings the bell. So in plane fib lamella excavation. So now this thin film in the earlier example was excavated perpendicular to the plane of view. Now the plane of view is XZ section, but the thin film is perpendicular to that, so it is not XZ. Now if I really want to do some detailed kinematic analysis, I need an XZ thin film, which means that if this is the XZ section in the field, then I make a rock thin section, I make a thin section which is XZ. From this, I scoop out a thin film, which is again XZ. Now that exercise was even more difficult, and it was done in banded iron formation from Norway, and that is the magnetite. And now this is the slicing has to be done like this, parallel to the XZ plane. So you do EPSG study of quartz in the K1, K3 reference frame, because as you see, AMS was done for this sample, then the K1, K3 plane was identified, then the thin section was made, which is K1, K3 as is mentioned there, and then you get a sense of shear. In this case, you see it is clockwise rotation for quartz. which means this pattern that you are getting is actually defining that this pattern you cannot get in a section other than XZ. So the K1, K3 plane is XZ, and then you have, this is an inverse pole figure map of magnetite. So you are able to identify the region of interest where there is some variation in the shades of color, which means there is intracrystalline deformation. And now we need to excavate a thin film which will be like that. So this was done. So now you see, in this case, the thin film is raised, removed parallel to the plane of view. So, and then this will be mounted on the TEM grid, and then the nanostructures will be investigated. So mark the orientation that there is a tungsten needle which is attached to the lamella. When we cut the tungsten needle and attach the lamella with platinum on the TEM grid, so you are leaving this mark here. And this mark you will be able to see under the transmission electron microscope. And this mark is parallel to X of the strain ellipsoid. And X is identified from K1 direction of AMS, okay? So now you have mounted it, you are able to now keep a track. Now once you know that where is that M, now irrespective of how you rotate the sample in the TEM, you know where is X direction, okay? So this was achieved, and two thin films parallel to the plane of view were investigated, and then the dislocation densities could be calculated in this sample. So these show dislocation creep, deformation mechanism. Again, this is magnetite, of course. You see, the dislocation density is of the order of 10 to the power minus 1 dislocations per nanometer square. And then there are other areas which show different dislocation densities. The interesting thing was that the orientations of these grain boundaries with reference to X direction of the strain ellipsoid are different. You see, some grain boundaries are subparallel, and some grain boundaries are at high angle, some are oblique, and they have different dislocation densities. So this is similar to the strain that you see in the field. You know that in the field, if you have a shear zone and the foliation curves into the shear zone, the strain increases towards the shear zone, but the angle between foliation and the shear zone, it reduces. So that is what we are seeing at the nanoscale. So this multi-scale modeling, we were able to also prove with the help of some numerical modeling that this is in fact also happening in halide grains, that as the angle, this reduces, you see dislocation density is rho, and angle between the low angle grain boundary and the shear zone, horizontal direction in this numerical model is, this angle is theta. So as this theta reduces, the dislocation density increases. So this example highlights the usefulness of integrating SEM EBST and TEM data for nanokinematic analysis. But then you see, as I gray and publish a lot of papers, and you become professor, and so you start realizing, say, what happens to the students, so what if you have done this? You get paper, but then the future, because Geological Survey of India is looking at future, and the future, as I wrote in one of my recent papers in the Journal of Geolsoc India, is to look and apply these things to fluid flow, mineralization, geothermal systems, nuclear waste disposal, storage, and so on. So you go collect an oriented sample, do all these studies, and then these days you can do X-ray micro-CT. You can get information about the 3D microstructure and then relate this with the petrophysical properties, porosity, permeability. We do SEM, EBSD, microstructure at different scales, incorporating TEM going up to nanoscale. And this, in my opinion, has a lot of scope for fluid flow and mineralization, geothermal systems, deep-seated nuclear waste disposal, and CO2 storage. Because ultimately it is the same principles that are being applied for these applied studies. So in my lab these days, we have students who are looking at all these different rocks in different projects, including one from Ministry of Earth Sciences under the Deep Ocean Mission. And then one can do fluid flow modeling using various possibilities, geochem foam, COMSOL, and then look at fracture topology, and then, or like one of my PhD students did, he used PACE 3D with collaboration in Germany to do the fluid flow modeling. And then this can help us address questions like these. How does alteration affect porosity, permeability, and fluid flow? How does vesicle distribution affect porosity, permeability, and fluid flow? Because some of these basalts from the ocean floor, they have vesicles. So the porosities will be different. How does foliation affect porosity, permeability, and fluid flow? This is a gneiss, that is a granite. They have different texture. Porosity, permeability will be different. How this will influence fracture network and the ability of the rock to be useful for, say, nuclear waste disposal. So there are many such, questions that can be addressed with this multi-scale analysis approach that I have been experimenting with, and this has a lot of application to society. So I end with these two statements by two brilliant people. Einstein said, intellectual growth should commence at birth and cease only at death. And our former president, APJ Abdul Kalam, said, have an aim in life, continuously acquire knowledge, work hard, and have perseverance to realize the great life. With this, I thank you for your attention.
Thank you, sir. Thank you, sir, for this engaging and conceptually enriching talk. So the floor is now open for questions. Anybody?
Sir, one question. So you said that in case of we don't have physical evidence of reference frame, we have logical reference frame based on the image data. But the image data itself, the interpretation of the image data itself also has very challenging because it is sort of integrate and the inverse fabric. Because of the harmonic effect and interaction of the magnetic field. So if you are not so according to the interpretation of the.
If we are not sure about the interpretation of the magnetic fabric, so then we are using this reference frame for the further study. So how we are avoiding, how we will avoid this challenge?
Yeah, so the problem of inverse fabric, etc., it is of course there, okay, and it depends on whether your sample is really strongly ferromagnetic or not. But in most cases, it is our experience that even in a thin section, you will find that the opaque minerals in transmitted light, all the ferromagnetic phases like magnetite, hematite, etc., they are dark, opaque. So the opaque phases generally are growing parallel to the paramagnetic minerals like micas and amphiboles, etc. So the problem, in such a rock, say for example granite, in our experience we never had, such problem. But yes, you are right, that problem of inverse fabric is there. So for those kinds of samples, generally then alternative, methods are applied, like doing temperature variation of magnetic susceptibility study to rule out whether the magnetite is really large single domain, multi-domain, or it is small grain of single domain. Because in those situations, you can have problem of this inverse fabric.
So, thank you. Any questions? One more question.
Sir, I have another two questions. Right?
Ah.
Sir, thank you very much for this information. Sir, I have two questions. The first question is
Your name and organization, please.
Sir, I am Arindam Das, medical geologist from GSI. First question is that, sir, you have shown some evidences of interdimensional deformation within the magnetite, different shapes. Sir, just I wanted to know whether, as in the case of quartz microstructures, we see evidences development of subgrains or bulging, braid boundary migration. Whether can we expect the same in magnetite?
See, the problem with magnetite is that you will see, normally under a microscope, you will identify magnetite in reflected light. In reflected light, you will not be able to see these subgrains and, intracrystalline deformation. There are techniques like staining the magnetite with ferrofluid. So sometimes the ferrofluid will stain differently. And then you might assume that this is because of subgrains, but that is not a proof. I think the proof is when you do EBST of magnetite, only then you are sure that this is intracrystalline deformation.
Then another quick question. That magnetite you have shown was a pure magnetite, I guess.
Yeah.
There is a difference in composition. Say we have foams in that type of thing. Whether the same thing can be applied for that?
Yes, why not?
It's not a big deal.
No, I don't think so.
Because we have one sensation I was looking at, it's an achromatic rock. I saw some evidences of chromite which are deformed. So this can be then applied for bones.
Yeah. Any mineral. See, this is a methodology. I have done it, applied it to magnetite. You could do it. Suppose if, like I am still interested in looking at nanostructures in quartz, because that is how my interest developed when I was interacting with Dilip Saha during my PhD days. So the same technique, excavating a thin film, looking at how the nanostructures look in quartz, it could be done there also. Any mineral.
Thank you very
Yeah.
much.
Thank you, Professor Montani, for a very illustrious lecture.
Thank you.
In fact, I get the impression that to move with time in the sense, the developments of science or particular science happening world over. So we should keep pace with it. And I in fact share as a field geologist that whenever we suppose we are not getting some stretching lineation or something at one outcrop, we shall try there, but we shall move to the next outcrop or that kind of lithology where such kind of features are available. So that's good, and I think you told very aptly that that application of this science is in the field of fluid flow also. So that's quite interesting, and I think your next projects will take some example from our nation and help in furthering our knowledge regarding the integration of fluid flow determined from the field features, major scale, and from our your kind of advanced studies. So thank you very much, sir.
Thank you.
Very, in fact, many, in fact, for me, many new things. Thank you so much.
Before we move on to our next presentation, may I now request Sri Rajendra Singh Garkhal, retired Director General, GSI, to please come forward and present our keynote speaker, Professor Mamtani, with a token of appreciation. So now we move forward to our next lecture, which is by Himanshu Saike and Purbajyoti Phukon. Anybody from the speakers is present here? Yes, sir. Okay. Yes. Yes, sir. We can move forward. Then Pitambar Pati, sir. Yes, sir. What do you call it? Yes, sir.
Before Dr. Pati starts, I request all the participants to introduce themselves so that we can questions.
इसका पॉइंटर इधर से जाएगा, इसका पॉइंटर वगैरह है कुछ यहाँ से कर लेंगे।
हाँ, राइट क्लिक
ओह सॉरी, ओके ओके ओके, respected chairman and the dignitaries present here. So after the wonderful lecture of Professor Mamtani on the hard rock, so I am talking you about a soft rock, particularly the sediments, and in the Ganga plain in particular, the most tectonically active quaternary plains in India. And this Ganga plain rupture, particularly due to this surface faulting, it is very well connected to these Himalayan tectonics. And we know this Himalaya is rising day by day, year by year, and how it is affecting this fluvial geomorphology and the tectonics of this Ganga plain. So I am here presenting with the help of terminal fans. So here the last line, if you see, it is written this, what is called? The terminal fans, it is a very interesting geomorphological or sedimentological feature in the recent days. So you might have heard about this alluvial fan, and which is close to this mountain front. And particularly this terminal fan is a very newly coined term, even if it is not so new. It is 1975 this term was coined, but somehow after 1975 it was vanished from geological literature. And in 2015, so we revived it, and finally it is found it is very much useful in detecting these tectonics, particularly surface faulting in fluvially active, or you can say it is the alluvial plains particularly. So if you see this Ganga plain, I need not to introduce much because of this time constraints. So here, this is the Ganga plain. It is bounded by the Himalayas from the north, and it is coupled and segmented along with the Himalayas. If you see, there are number of basement faults which is starting from this peninsular, and it is going through this Ganga basin, and it is cross-cutting the Himalayas, few of them. So number of faults, they were present pre-collision, and they are reactivated due to this collisional tectonics. And some of these faults, they are also formed in the recent days due to this collision. In addition to this basement fault, there are a number of surface faults. So here in the next figure, I will show you there are a number of surface faults in the quaternary sediments, and those surface faults, they are playing this key role in forming these terminal fans at their downthrown side. So here if you see this glimpse of on this terminal fan, particularly if you see, this is the alluvial fan which is close to this mountain front, but now if you are moving hundreds kilometers away from this mountain front, in this plain particularly, you are getting small faults, surface faults they are occurring, and on the surface fault if you see in this side, are you pointer can't be. Oh. Here if you see, either it is a normal fault or it is a reverse fault. Here what is happening, this due to this micro topographic break, the sediments are getting eroded from this upper block and it is depositing at the lower side or the downthrown block. And very interestingly, whenever this alluvial plain and this fluvially active, these sediments which are eroding from this top and depositing at this bottom, it is time-wise, it is more or less equal to this time of faulting. So that's why if we can date those lower sediments of this fault, that we can roughly say this time of faulting itself. So in this figure, you see this terminal fan, the sediment, very thin sediments. If you see here, now the very key factor is that why it is called terminal fan, because you see all these channels, they are terminating at the fan boundary. So I am getting a problem with this pointer. Here you see most of this channel, or you can see all of these channels, they are terminating at the fan boundary. That's why the name terminal fan was given. So now if you see this termination of this channel, here you see this remnant of this channel is here, and this at the terminal site, when we carried out field work with excavations, we found that there are these evidences of channel terminations, and that means it is showing there a thin pile of sediments. They are representing these terminal fans, and the bottom of this sediment, it is representing the date of faulting. So in this Ganga plain in particular, if you see, there are number of terminal fans. You can say around 45 to 50 terminal fans were found, and all these terminal fans were dated. So based on the date, you see, there are three major phases of faulting that are identified, even if there are number of faults in the Ganga plain, but this faulting process is not continuous. There are breaks in the faulting timing. So if I arrange this timing of this terminal fan formation starting from the oldest to youngest one, वो कहीं गायब हो जाता है यार बीच में. Oh, yes, here. So pointer है नहीं शायद. So starting from this oldest to youngest one, you see there are perceptible breaks. And those breaks, they are representing not the time of faulting. So that means.
Kindly help him with the pointer. Pointer is having some problem.
So these are the breaks. So now the question arises, if I am arranging these breaks in time with these climatic change events, so I found there are number of events like M1, that means major breaks. This capital M, this representing the major breaks, and the small m representing the smaller breaks. So that means what I want to say, there are 6 episodes that measure, including major and minor. There are 3 major episodes more than 500 years, and 3 major minor episodes around 500 years. So here the episode 1 starts at 9.38 and ends with 9.1. Similarly, the second episode, this timing frame is given. Third episode, like similarly, the 6th episode is there. So now what is happening, if I am arranging these episodes with a time and going for linear regression analysis, what I found that this arrangement of this episode's initiation and this episode's termination, they are representing straight lines. And they are perfectly fitting with this straight line, with these R square values of this much. So that means what I want to say, these Ganga plane tectonic ruptures, they are occurring in a different time intervals, and this time interval, if I calculate it, it is coming around 668 plus minus 1.150. That means around 700 years so. So with the published data, so with the published data, if I compare my studies, so there are number of people, they have worked at different segments of the Himalayas. So someone is Assam and Shillong, sorry, eastern Nepal, central Himalayas, and this part is the Himalayan arc along. So here there is a Gupta and Gehlot in 2014, they published all this around the Himalayan arc, and they found if you see this time years, the time gap around 700 years or so. They're starting from here and it is going up to here. This age or the time, it is following around 700 years. So that means what I want to say, this Himalayan 700 years cycles of major earthquake occurrence, it is also coinciding with the Ganga plane surface rupture cycle around 700 years or so. So that means what we can say, this Ganga plane rupture cyclicity, it is also following this Himalayan rupture cyclicity also. That is this theme of this presentation. So thank you very much for listening to me. Any question you can ask.
Thank you, Dr. Pradeep, for a wonderful piece of work that you have shared. The forum is open for discussion. You can have a couple of questions, please.
Thank you. Is there any, this is like 10,000 to 600 years before present?
Yes, 750,
Any historical records also which you
which is included here. Included here.
Okay. And
Yes.
there too it's like a 600 site.
Yes, sir. Yes, ma'am.
So what do you predict for the future in this area?
So we have identified few areas within the Ganga plain, particularly the central Ganga plain, where the stress is accumulating now because by help of this fluvial geomorphic response, we are getting this starting from this Pokhara fault and the west. So this area is vulnerable for future earthquakes. So most of the stress is accumulating there based on these fluvial geomorphological evidences.
But in Nepal we've already had a stress release in 50 and in 2 years back.
Yes, yes. In 2015, there is an earthquake, 7 point some magnitude earthquake. And very interestingly, if we say this is the major earthquake that are occurring, so that is the time 0. Nowadays it is happening. It is time 0. So the 700 cycle, the 700 and 700 and 700, and this Nepal earthquake, it is coinciding with it that 700 years. So that means you can say this graph is continuing with that. So that is the point of that graph.
So any kind of, you see, you can link it with the examples worldwide, especially the 700 year cycle?
No, sir, in worldwide we cannot compare it because this Himalaya is somehow different than the others.
Okay, India is there, Gangas are there, then Nepal suppose, or Bhutan, or somewhere Bangladesh.
Sir, this time it is very premature to say something on that. Probably in future research we will be able to come to a conclusion and answer your questions.
So I have one thing I should like to share here. You see, in 2001, Kutch has earthquake there, Kutch Gujarat earthquake there. Before that, we were sitting in a room in Geological Survey of India. One of our colleagues told, before 2001, that there will be earthquake in the Gujarat. How can you predict that? So it's a kind of establishment from the persons who have not worked in the kind of situations in the quaternary tectonics or in disturbances in quaternary. He said stresses are building up, and once the earthquake is there, we were all stunned and we congratulated for his predictions. So I think what I want to say is the thing like you told that
Sir.
So that level of stress, which will ultimately result. So these are the kind of things I think you will continue.
Sir.
Thank you very much.
Okay, sir. Thank you so much. Thank you.
Pati sir, thank
Who
you
is
very much for
asking?
the-
Okay.
very much
Okay.
for the presentation. I have one question. The
Sir.
southernmost thrust that we know in Himalaya is the main fountain thrust.
Sir.
Now, when we are talking about rupturing the Ganga plain is in the south of main fountain.
Yes, sir.
Are we looking at development of a new thrust?
Sir, there are already published results. So by us in 2011, particularly in the Bihar plains, there are number of thrusts which is south of this MFT. They are within that Ganga plain sediment. And in Delhi, near to Delhi, there was a publication in 2014 or so. So they have also found the parallel thrust, which is parallel to the MFT. They are also originating near to Delhi also.
Even southern than the main fountain.
Yes, yes, yes.
That means that we are perhaps
So this deformation is migrating towards south.
possibly the Nicole
What you see in the lab,
absolutely.
real time is
Absolutely. Possibly the Nicoloma is manifesting further south.
And even in Banaras and all, the Ramnagar formation, there also a tectonic activity 40,000. There are many such activities.
While doing field work also, we found the reverse fault in the Ganga plain sediments. Reverse fault. So normal fault is common particularly, but reverse fault is uncommon. But we found reverse fault in the Ganga plain sediment. It is much, that means far from this main frontal thrust. Yes. Okay, thank you, sir.
Nice talk, sir. I have one small question.
You can continue later on. Previously, over to the next speaker.
Let us proceed to the next presentation, which will be by Prantik Satra, who is our colleague from GSI. In this.
Hello, good afternoon. I'm Prantik Santra, a geologist from RSS GSI Bangalore. So, since the morning we are hearing lecture about the significance of presence, someone talking about presence of some texture, some mineral, and some structure, but now I am here to talk about the absence of a mineral. So I will talk about a rock, a mafic granulite, where orthopyroxene is absent, and what is the significance of that absence. So our team, I, Dr. Rigzin Norbo, a geologist from State Unit Karnataka and Goa, and the present HOD RSS, we did a work on the mafic granulite from the Markara shear zone at the southwest part of West Tharbar Craton. So where is that? So from the first image, we can see that the peninsular India is made up of 5 major cratons, starting from Singhbhum, Bastar, Bundelkhand, Aravalli, and Dharwar. and Dharwad is one of the largest craton of the peninsular India. Now, in the mid image, it is the generalized geological map of the Dharwad craton, and at the western part, the western Dharwad craton is present. And if you take a traverse from the north to the south of the West Dharwad craton, the metamorphic grade increases. That means if we are moving towards the south or doing the field work in the south, we are supposed to get granulite grade of rocks. Why? Because it is believed that the tilted earth crust is exposed there in the West Dharwad craton. Now, in contrary to this concept, in the last decade, most of the people are believing that not only that, there is a block, allochthonous block, that is the Kurg block, we can see here, and that is a granulite block that is amalgamated to the West Dharwad craton along this Markara shear zone. And this Markara shear zone, when this amalgamation happened, there is a lot of debate on that, but still people believe it happened during the Meso-Archean. Now our study area is across this Markara shear zone. So in coming few minutes, I will talk about the field disposition and the mineral assemblage of this orthopyroxene free mafic granulite. Then what is the importance of this rock? Why should we study this? Then the microstructure and the geothermal study we carried out to build a conclusion. So this is the geological map of the area which we have prepared during our STM field work in the time frame of 2019 and 23. So we can see in the left-hand side, this whole area is divided into 3 blocks. Depending on, so at the northeast we have WDC, the West Dharwad craton, at the southwest we have Kurg block, and in between we have the Markara shear zone, which is the amalgamation zone between these 2 orthogneiss dominated crustal blocks. Now, why we have divided these 3 blocks? It's depending on some contrasting lithostructural assemblages and obviously the grade of metamorphism. Now, in the inset map, we can see that mafic granulites are present as small detached bodies within the felsic orthogneiss. So now we'll go in deeper into that. So in the field, we can see the mafic granulites are encased within highly deformed felsic orthogneiss, and they are boudinized, and they are present in various scales, so their dimension varies. Now, in the second image, here we can see it's there are some colorful mineral assemblages. The red is garnet, the CPX is dark green, the white colored plagioclase, and the black colored amphibole. These 3 photographs are photomicrographs. The first one is showing a granoblastic mosaic made up of CPX, garnet, plagioclase, and later it is replaced by amphibole. The fourth one is a porphyroblastic garnet, which contains numerous inclusions of CPX, plagioclase, and quartz. And the last one is actually showing the garnet is again breaking down by developing a symplectite around it. So what is the major takeaway from all this? That our rock doesn't contain OPX in any phase of metamorphism. Now, why should we study this rock? Because if we go back to our classroom lectures, so these particular assemblages like OPX free but garnet, CPX, plagioclase, and quartz bearing rock doesn't come under typical granulite or iglogite. Because why? If we check the phase diagrams, in the granulite, we are supposed to get OPX as a mineral, index mineral. And if we go to the iglogite, we shouldn't expect plagioclase in our system. But here we don't have OPX, but we have plagioclase. So this rock, this assemblage could be in a zone which is actually connecting the iglogite and the granulite. But the life is not so easy here because this kind of assemblage is just an indicative thing, or we can say it's not a definitive thing. So that means if we get this kind of rock, it don't give us the freedom as such to say it's a high pressure granulite. So we have to study some more other proxies to talk about that. So yes, the structural evolution of the metamorphism study in our area, it shows the early assemblages, that is the M0, that is actually present as a relic within the porphyroblastic garnet as inclusions. So in that case, we have inclusions of clinopyroxene, plagioclase, amphibole, and quartz. In the peak assemblages, we have the granoblastic mosaic that is made up of garnet, CPX, and plagioclase with quartz, and these quartz are free quartz. Now, within that, the plagioclase is very less calcic. So we can see the anorthoid number of this plagioclase is around 40. Now the retrograde assemblages where the garnet, CPX, where we are getting a symplectite rims that is made up of magnesio hornblende or pergasite along with plagioclase. And here the plagioclase, the anorthoid number is very high. It's very calcic and it's around 0.86. So we have deduced the reaction which is showing that the all the prograde minerals, they are breaking down and giving rise this symplectite. So garnet core, clinopyroxene, albite, quartz in presence of water, it is giving rise the garnet rim, anorthite, and hornblende. So now to deduce the exact pressure temperature condition of our rock, we did the conventional geothermobarometry as well as the pseudo-section from Parplex. So the geothermobarometry study shows the peak assemblage, the M1, yields the pressure temperature condition around 12.3 plus minus 0.7 kilobar at a pressure of more than 850 degrees centigrade by using GCPS and GC systematics. And for the retrograde assemblages, it is showing 7 kilobar pressure and 570 degrees centigrade temperature from the Hornblende plagioclase and the aluminum in a Hornblende systematics. Now for the pseudo section, we have determined a bulk composition for a microdomain where the reaction is happening, and that is given in this orange table. And for this pseudo section, we have taken quartz, fryolite, and magnetite buffer because we had magnetite in our system. So from that, we can see that we have created a phase diagram in which we have so many zones, and in those zones, some typical mineral assemblages are stable. Now we can see this big zone. Here we have plagioclase, garnet, CPX, and quartz, which is actually the assemblage which we have at the peak metamorphic condition, but it's a huge zone. So we narrowed it down by cross-cutting the isoplates of the peak assemblages, and it gives this zone as the M1 pressure temperature condition. And we have done the same thing for the M2. Now, so this M1, which is coming from the pseudo section, and what we are getting from the conventional geothermobarometry is almost matching. Now, additional to this info, which is actually showing a granulite grade pressure temperature condition. Now, in addition to this, we doesn't have the hornblende at the peak, and we have less calcic plagioclase and the garnet at the peak. So if we go back one slide, so yes, as we are saying that this assemblage could be a link between the iglogite and granulite, but this kind of assemblage again may occur at the higher grade of amphibolite, and it may be a complete phenomena of bulk composition. So by doing our study from all this, we are showing that we don't have hornblende at the peaks, and we don't have highly calcic plagioclase or highly calcic garnet at the peak, so these are not from the amphibolite. And again, along with that, we have free quartz at the peak metamorphism condition, so it is again showing it's a high pressure condition. So all our inferences are pointing out it's a high pressure granulite. So at the end, I want to say that the peak assemblage of the mafic granulite from the Markara shear zone is actually free of orthopyroxene, and it is actually showing a high pressure metamorphism corresponding to 40 kilometer crustal depth, which is done by crustal thickening by collisional tectonics. And so it's a rare assemblages. We should study this because it's a link between the plagioclase-free iglogite and the OPX-bearing granulite. Now, most of the workers from the outside of GSI who have done the work on the collisional tectonics on the Markara shear zone regarding the timing of it, they have mostly pointed out that it's a Meso-Archean collision. And they have said that that collision marks the highest metamorphism of that area. Now, as we know that in the Archean, the prevalent type of metamorphic condition was high temperature and low pressure. But such example of our rock which we have done, the high pressure, moderate temperature metamorphism, it marks an exceptional tectonic condition in the Archean scenario. So yes, thank you. That's all from my side. At the last, I want to give my gratitude to my team members and obviously the team working behind this whole gala. And thank you to Geological Survey of India and Ministry of Mines. Thank you.
Thank you, Prantik, for a wonderful lecture. You have brought field injection, electric geothermometry, and yeah, please, the floor is open for question. Please introduce yourself before you ask the question. We can have one or two questions.
Thank you. I guess like my rock, I am also free now. Thank you.
You presented very nicely,
Yeah,
so thank you very much.
yeah. Thank you, sir.
Let's move on to the next.
Which one?
The next presentation will be given by Arupratan Manna.
Good afternoon, all. Today's topic is basically the crustal collision and reshaping, Singhum orogene's legacy in the Dhanjari Basin. This work we are presenting now, that is basically our, we have carried out during our Uncover project. And the first author, Saptarshi Mullik, actually, due to some unforeseen incidents, haven't been able to present here. So I'm presenting on behalf of him. So all of you know that in the Singhum crater, in the northeastern fringe, there is a volcano-sedimentary basin. This is Dhanjari Basin. So we are basically, previously the work related to Dhanjari Basin is basically related to lithostratigraphy only. And in the present work, we have basically establishes some the tectonometamorphic stratigraphy of the Dhanjari Basin. So this is the previous stratigraphy, lithostratigraphy of Dhanjari Basin by Bosu and Singh, Gupta et al. So here we can see they have divided Dhanjari into two formations. The lower formation is basically basal quartzite overlain by quartzite and some tufaceous sediments. And the upper Dhanjari is basically metabasalt dominated along with some quartz mica schist and mafic ultramafic intrusives. This is later on modified by Acharya et al. In 2010. So they have divided into three formations. Basically, they have made another formation in another division in the lower Dhanjari. That is basically a Fuljari formation is the lowest one. And subsequently, they have divided it into another two formations. So deformational history, previously documented deformational history. So Bosu and Singh basically recorded two phases of deformation. And later on, Modak and Singh establishes another third phase of deformation that is basically related to a warp. So now, during our Uncover project, we have basically from IRS lease image, we have traced out lineaments. So here we have found some intersecting lineament. So from which we are basically inspired to carry out this lithotectonostratigraphic study. These intersecting planes, we thought this will be some discontinuity. So these are basically lithological description of Dhanjari Basin. So this is basically basal quartzite. This one is the basal quartzite. These are the sandstone. This is phyllite. And this is basically stage lapilli stone along with one class of volcanic bomb. This is basically lapilli stone, stage lapilli stone. This is basically agglomerate. And these are the metabasalt, amygdaloidal metabasalt. This is also foliated metabasalt. So from the IRS lease imageries, we have demarcated three sets of shear zones, shear splay zone of Singhum shear zones, which we have validated in the field also. So this is the map we have prepared. These are the structures related to myelinitization in Dhanjari rocks. This is basically C prime fabric development. Here also you can see these are basically shear related fault. Tomorrow I have one presentation. We have another poster presentation where I have detailed these fault geometries. So these are basically stretching lineations, and you can you will see that the myelonite plane is folded into this fashion. These are also these folds are basically developed within myelonite fabric only. And there is another set of that is basically related to strain release kink fracture. These are basically perpendicular to the myelonite plane. So now you can see that in the we have found some clipe rocks of NSMB in the Dhanjari main part of the Dhanjari rocks overlying the Dhanjari rocks. So these are the S0 fabric of Dhanjari. This is the C pole stereonate plot of the Dhanjari rocks, and this is the C prime. So all of them are making northwest to north-south, northwest southeast to north-south orientation. In the NSMB fabric, we found the same. So that is basically related to myelonitization, and the myelonite plane also oriented in this same fashion only. There is no other fold actually in the Dhanjari basin, deformation related fold. Otherwise, this S0 plot would have been different. And this is the stereonate plot of the kink fracture sets. This is in the close proximity where clipe and the Dhanjari rocks, clipe of the NSMB and Dhanjari rocks are the data is representing. So we can see both fabrics are making this northwest southeast sense. So what are observation? Basically, Dhanjari is basically a single stack volcanosedimentary assemblage, and the repetition what we found in the previous stratigraphy is basically due to thrust stacking, fold thrust related stacking. We have found northwest southeast myelonite plane, which is represented by basically C and C prime fabric. And another fabric is there, which is also northwest, southeast in orientation. That is and dipping opposite side, dipping basically southwest side. This is basically related to the strain release of the myelonitization. So we have demarcated the shear fabric in satellite imagery also. So now you can see these are the shear planes we have drawn, and here you can see the quartzite is overlying below the metabasalt. Normally metabasalt is a overlying sequence, but here due to thrusting, this is the underlying sequence. This is the overridden thrust sheet of quartzite. So these are also the thrusted NSMB rocks. So how we differentiate NSMB with Dhanjari rocks? Anybody can ask that question. So basically NSMB is metamorphic grade of the NSMB is higher comparatively Dhanjari. In NSMB we found quartz biotite staurolite bearing rocks also. So that is basically in a higher grade. So that is also forming myelonite fabric, and that is basically we found in the main part of the Dhanjari basin only, sir. This is the outliers present apart from the main part of the Dhanjari basins, which is basically undeformed in nature. So our observation is that Dhanjari was basically an undeformed basin, undeformed platformal basins, which develop, which preserve deformation of related to only Singhung shear zone related deformation. Otherwise, the previously documented fold related deformation is not present in the Dhanjari. This is another intrusive, ultramafic intrusives that is basically undeformed in nature. So we have placed it in the after, this is basically late to post intrusives. These are ultramafic. This is the Arkasani granite, soda granite. So we have prepared a model of Dhanjari like this one, where these ultramafics are basically post to late kinematics in nature, as they are occurring near the shear zone, in close proximity to the shear zone, and this is basically undeformed in nature. So our conclusion is basically Dhanjari single stack volcanosedimentary basin, which is basically conglomerate quartzite phyllite to metavolcanics bearing, and this Singhung shear zone developed at the later phase of the progressive deformation of the Singhung orogeny. Dhanjari rocks developed this mylonite fabric. Prior to that, Dhanjari was basically undeformed in nature. And these ultramafics are basically related to the late to post intrusives. As we found it in the close proximity of the shear splays of a Singhung shear zone, we thought it was basically related to late shear event only. So this is our modified stratigraphic table, lithotectonostratigraphic table. So here we will see that Dhanjari is deposited over cratonic basement, and NSMB is basically a mobile belt. So the initial phase of Singhung orogeny, deformation phase of the Singhung orogeny are preserved in the NSMB rocks, but that is absent in the Dhanjari rocks. Later on, during late phase of the NSMB orogeny, Singhung shear zone develops during accretion of the craton and mobile belt, and during that time, Dhanjari develops mylonite fabric. Thank you.
Questions, sir? Quick questions? Sir, please.
Interesting question, interesting presentation. Do these ultramafics have olivine?
Yes, sir. That is basically pyroxenite to peridotite in nature, sir.
Because it might be interesting if you did some SEM EBSD studies of this olivine.
Yes, sir.
Because that can give you some information about olivine deformation,
Okay,
which
sir.
you could relate with this very interesting, structural geology that you are building up. And another thing is that is this you somewhere, I don't know whether I misunderstood, somewhere you said that the myelonetic foliation is folded.
Yes, sir. That is basically related to progressive shearing only, sir. That is shear related fold only there.
So it is during the same deformation.
Yes, sir.
Not,
In the same shear progressive shearing process.
So
sir.
have you seen sheath folds there in the field?
Yes, sir. But tomorrow I have a poster presentation. I will make detailing in this.
Banda sir, the questions asked by Professor sir, kindly keep these in the mind.
Yes, sir.
I do feel that the kind of interpretation you have made and the data you presented does not seem to be perfectly supported. So don't take it as a criticism, but further concentrate. Number two, you see, you said that intrusions are related to some shear after shear or shearing. So this also you look
Yes, sir.
But how can we link the shear and intrusion? Kindly see it. So thank you very much. You are from GSI?
Yes, sir. Yes, sir.
Thank you very much.
Thank you. Thank you, sir.
We will now move forward to our next presentation, who will by Dr. Krishnapriya Bosak ma'am. Ma'am, mic টা চাই? ঠিক আছে। পয়েন্টটা করে দেবো?
Good afternoon, everybody. I am Krishnapriya Bosak from Southern Region, Hyderabad. Today, I am presenting on a topic that is in situ UPB zircon analysis of granitic gneiss of conical schist belt, Karnataka, India. It's an evidences of paleo and neo-Archean crustal growth and reworking of older crust as at East Dharwar Craton. Dharwar Craton is one of the oldest cratonic nuclei of India, and it is the most well-studied craton of India, rather. So this is a generalized geological map. Since long back, work is going on, geological work has been going on, and based on huge amount of data, earlier workers have divided Dharwar Craton into two. So Aminathan et al. In 1976, it's an East Dharwar Craton and West Dharwar Craton, based on definitely age of the granitic gneisses, presence of high-grade supracrustal rocks within the WDC, whereas in EDC they are mostly lacking, and gneisses of WDC are much older, and whereas in EDC they are much younger. So even based on the geochemistry, SMND data, so people have compiled all the data and have divided the whole Dharwar Craton in two. One is West Dharwar Craton and another one is East Dharwar Craton. And the boundary between these two Dharwar Craton is just at the, how can I, okay, here. You can see over here, this is the Chitradurga schist belt, and this is the Chitradurga East margin shear zone. This is supposed to be the boundary between the EDC and the WDC. Later, Pequot et al. In 2013 again come up with another hypothesis, that is there must be three cratonic block. One is WDC, then it is CDC, and then there is EDC. But a lot of data also has come against this theory, because in the EDC and CDC, this boundary is not so clear, number one. And even the data are also, I mean, they are not corroborated with this theory, which is coming in the latest, in the last decades, in the publications rather. So what we have done, actually, in WDC, we found a lot of high-grade supracrustal rocks, which I used to tell Sargu groups. These are the Holanarsipur schist belt. And so what we have taken, this is our study area, and there is only one high-grade supracrustal belt is present in this part, just near the Chitradurga East margin shear zone, that is called conical schist belt. It occurs very nearby the shear zone, actually near the boundary, at the boundary of the EDC and WDC. And we have carried out some work over here, structural as well as some geochronological work. In my presentation, I will show you the geochronological data we have got from this work. And now, here, sorry, I have to show here. So this is our area, and if I just go to the second slide, this is the study area and this is the map. And you can see this is the Chitradurga East margin shear zone. It's going like this, and conical schist belt. You can see this schist belt is also extremely sheared as per our structural mapping. And we have collected gneissic samples from here, that is Huliyur Durga, and there is Madur, Tippasandra, Bilidevala, Albanagudda, and all of these gneisses, except Madur gneisses, all of these gneisses are intrusive into the conical schist belt. Other gneisses, the Madur gneiss, which may be the older gneiss, as due to the shearing, the boundary between the conical schist belt and the Madur gneiss has been obscured, completely sheared, so it is really difficult to tell whether it is older or younger, but rest of the granite actually has a very good field relation where you can establish, well, conical schist belt has been intruded by the younger gneisses. Now, this is a tectonic model given by Abhinav Rai and Shilayuta Sengupta in 2017. And you can, over here, you can see this is the Yedu schist belt, one of the low-grade Dharwad supracrustal at the western part of the Chitradurga East margin shear zone. And this is actually the conical schist belt, this part. And here, these are all the granitic gneisses. So what we have done, we have collected whatever samples we got into this gneissic terrain. And so if I just go into the next slide, you can see this is the older Mudur gneiss. Sorry. This is the Mudur gneiss over here, and which has been inundated by later leucogneisses, some sort of. And whatever we have seen in the Mudur gneiss, these are extremely sheared, and there are leucosomes which are folded. And here you can see both the leucosomes, as well, not the leucosomes, leucogneisses, as well as the Mudur gneisses, they were also folded. So what you can tell, that all the older gneisses, whatever present within the conical schist belt, were affected by the later shearing event, resulting in development of shearing bands, asymmetrical folds, small-scale parallel shear zones, type 2 isochronal folds with shallow northerly plunging minor folds, blah, 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 whatever we are getting, which is matched with the major shear zone of the Chitradurga East margin shear zone. So now, if I just come to the next slide, you can see these are the intrusive granitic gneisses, which are also deformed. But these gneisses, at least we can establish from the fieldwork, there is in the seen D1 intrusion, they are intrusive into the conical schist belt, and invariably affected by the later shearing, even resulting in development of shear bands. Even you can see the amphibolites here, over here, amphibolites lenses, and this is strongly banded feature, and here you can see the shear bands over here, and also definitely these are the different type of gneisses, Tippasandra, Vilidevala, and Huliud Durga. So these are the 4 gneisses we have collected from here. Now, if we just go to the Mudur gneisses, you can see from the zircon, is a very nice oscillatory zonings over there, and aspect ratio is really high. Even the thorium-urium ratio is more than 0.5, so we can definitely take it as a magmatic, evidences of magmatic crystallization. So Mudur gneisses, it represents the magmatic crystallization, granite. But you can see the age is nearly 3322 plus minus 24. So this is another evidence of an older gneisses, which is mostly present in WDC, but it is also present in EDC. It's not like that EDC is completely devoid of older Archean gneisses, but here we can also find in EDC, these are the older gneisses. So the prominent cluster is mostly 2.9 to 3.33. Actually, this is a very discordant age. I will go to the explanation why it is so much discordant over here, because only few data are lying over the Concordia. Rest of them are showing, rest of the zircons showing lead loss features. Only the upper intercept is giving you the Archean age. Then the intrusive granites of Tippasandra, it is also a very discordant age, but the aspect ratio as well as the nice magmatic oscillatory zonings are present over there. So, and the ages, we have considered those ages, we are mostly concordant with the Concordia and the upper intercept, which give us the age of 2598 plus minus 24 MA. But there is another interesting thing is there are few zircons. If you just go to over here, you can see there are few zircons, at least 7 numbers of zircons in our population. It is giving Archean age of 3300 MA. They might be represent either xenochrist, which is derived from the earlier existing older gneisses, and it is also from the EDC part. So there are 2 things. One is the xenochrist of the older Archean gneisses, and definitely the later magmatic 2.5. Same for the Vilidevala granite gneiss. If you can see, this is also a very discordant UPV age, but the concordant ages and the upper intercepts are giving 2572 plus minus 57 MA, and you can appreciate the very nice magmatic crystallization with the high aspect ratio, oscillatory zoning. So, and there are also very few zircons we are giving in over here. You can see 3350 MA, which might reflect age of older Archean gneisses. So at least we can say that there are gneisses which are much old of 3.3, which has been reworked during this 2.6 gigaannum. And this is the last one, that is the Huliud Durga granite gneiss. Again, all 3 are same. You can see over here, this is also discordant age. It is giving 2598 plus minus 24. But in the Terra Wasserburg, you can see there are distinct population. And here also, again, you can see in situ UPB analysis. And there are 2925 to 3401 few zircons having Archean age. These are also representing xenochrist. And the probability density plot also showing the Hulir-Durga granite, large number of data near 2600 MA with few Archean grains. And now, whatever data, I have shown, they are mostly all samples yielded discordant ages. And we are showing the 207 late by 206 late, which has been taken as the approximate estimation of the magmatic crystallization. And discordant UPB ages are mostly due to lead loss, because as we have collected samples from near the shear zone, and all the rocks, though we have tried to collect samples from nearly undeformed rock, but all these rocks have been suffered extreme shearing. So during that part, all the lead, a number of zircons have lost their lead. So there is a strong feature of a lead depletion during the time 2.56 to 2.62. So we can say discordant UPB ages due to lead loss during shear-assisted emplacement linked with 2.56 to 2.52, juvenile magmatic accretion and crustal reworking. And due to large uncertainty, only the upper Concordia were considered. And those data, okay, it's not an analytical error, because we can show you the UPB age of the primary standard, because all we have dated in a sample standard bracketing. So all these standards they are very well corroborated with the Plisovis and the 91500 standard zircons data. So what we can conclude that zircon grains of the intrusive granite gneiss are large, euhedral, prismatic, with concentric growths, definitely with high aspect ratio. They are all of magmatic crystallization. Older gneisses in the conical schist belt aided a prominent cluster of 2.9 to 3.33. So there are older gneisses in the EDC, but they were reworked and inundated during the later 2.6 gigaannum. And most of the major younger granitic activity partially or grossly obliterated the older crustal component, leaving only small isolated remnant vestiges, if you just can remember the older our model over there. So at least we can conclude the presence of a wider range of older crust at the EDC, which occurred either as a separate body or as xenocrest, and then younger gneisses representing SIN D1 and D2 granitic intrusions engulfing KSB, and Neoarchean UPB age of 2.60 gigaannum derived from the younger intrusive gneisses. They represent reworking and definitely addition of crust. And so thank you, everybody. And I must acknowledge GSI, definitely, our DDG, ADG, all, but the person whom I really want to acknowledge, that is Dr. H.M. Ramchandran, who is no more, and who was present with us all along the field. So I simply express my sincere gratitude to him. Thank you.
Thank you, sir. Okay. You see, first of all, presentation was excellent. We could understand what you were speaking. Mumtani sir, कुछ पूछना है sir? No, nothing. Okay. So I think this is the best part. That whatever you speak, it should be nicely supported by photographs and figures and all. And if there is a clarity in the voice, audience get what you want to convey. Again, this H.M. Ramchandra,
Yeah.
I also happen to know him personally, and really is a Zimbabwe person,
Yes.
very learned person,
Yes, sir.
very selfless person.
Yeah.
So thank you for the presentation.
Thank you.
The next presentation is by Durga P. Mohantya and team. Is there anybody here? Okay, sir, then that was the last presentation of this session. So,
Yeah, thank you, all the presenters. Really, it was a very learning experience for me going back to classroom with Professor Mamdani, where I left
if we step up with the kind of things which are already available in the literature, so maybe that at least a kind of weight is added to some particular evidence. So this kind of study will help, I think, if you can take up the project.
Yeah, actually, since you have mentioned this, sir, today itself I was discussing with Praveen, because as you people have, everybody in the audience has seen that there is an MOU which is signed between IIT Kharagpur and Geological Survey of India. So I was just discussing with Praveen and some others that how we can move forward. And in the exhibition hall, I have seen that there is a poster, related to the national data repository that you have, and there are some beautiful core samples which are presented in that image, poster. So it just occurred to me that what Shekhawat Saab is saying, that these types of samples, if they are available in GSI repository, these can be used by, in this collaborative mode project to look at such fabric analysis, at least, forget about TEM, but at least AMS, SEM, EBSD, and X-ray micro-CT you are able to do in India, in many places, in IIT Kharagpur, for example. So it should be easily possible, at least if we have the samples. Up till now, the problem with our country is that people just don't give samples for any study to academia. So if that is possible, then I think it is a win-win situation for everyone.
Whether it is GSI or you, MOU is already there. So let us hope for the best. Things will come up. And samples are there, and providing samples is not a problem. But the old era problems are, I think, gone. We are moving ahead, and let us hope the best possible outcome of your collaboration. Thank you very much, sir. Then Pitambar Pati Saab. Yes, I said, I in fact shared my experience with our colleagues working in Bhuj area prior to the Bhuj, the Kutch Bhuj earthquake. Similarly, here also there is a scope. I think Japan has done a lot of work on it. So we can learn from them. Besides learning, you said 660 years, it's all right. But you see that break-in period. Break-in period means the intensity of the kind of microstructures which you have got in the quaternary, when did they fail to cause the earthquake? So such kind of intensity, not simple intensity, intensity which is worked in the structural geology, all parameters, its amplitude, its wavelength, everything combined. So I think you must be doing, but learning from the experience of the countries from where a lot of earthquakes are taking place. Number two, learning from our own experience. GSI is also doing some tectonics kind of study. Madam Basak has presented very nicely, and I think that map itself was so illustrative that you can see the clear-cut displacement, and of course that kind of clear-cut zoning which is visible in the zircons. So such kind of work should continue to of course maybe ultimately we must link everything to our critical minerals or say mineral exploration or to societal issues. So this is a big challenge, but I think we must all start thinking on those lines. Manna sir presented, and of course it seems that some of the inferences drawn are not fully supported by the evidences, kind of evidences or kind of geological map and various units and he has shown. So I request Manna sir to look into this criticism or this observation also. And I think this is the last. So thank you, sir. It's a quite learning experience. We listen to all. Or thank you for listening to us also. Thank you very much to all the speakers and audience. Thank you.
Thank you. Thank you to all our speakers, our chair and co-chair for their valuable insights. Thank you for the audience for their active engagement. And we had some thought-provoking discussions on scientific advancements, and we hope for fruitful collaborations in the future. I now invite Srimati Jaya Chauhan, Ma'am, Director, GSI Western Region, Jaipur, to please felicitate our chair, Dr. Shekhawat, and our co-chair, Dr. Bibhash Sen. Thank you, ma'am. With this, we bring the deliberations to an end of this session, and we invite you to join us for high tea. Thank you.
and geocollections. So if you want to know more about it, this is the website where you can find information on the criteria and the objectives. Everything is recorded very well on the website. So we have three main pillars. The subcommission on geosites talk about the natural sites, which are interchangeably used by people as geoparks or geoheritage, but this is one of the important pillars of International Commission on Geoheritage, where we talk about natural sites. The second pillar is heritage stones, which are the stones which have been used in monuments, the monuments which are man-made. The third one is subcommission on geocollections, where we talk about museum collections, which are housed in museums, and we can identify those collections based on the merit, and these are also designated. For example, I just got to know during lunch when I was interacting with Dr. Snigdha that India also has proposed 2 proposals as collections, geocollections from India, and hopefully they'll be ratified. So quickly we'll go through the definitions or the concepts related to geosites, heritage stones, and geocollections. An IUGS heritage site is a key place with extraordinary geological elements or process of the highest scientific relevance used as a global reference. Now, why I call it as a global reference? Because every site is interesting, has a geological process which leads to its formation, but there are certain sites which we identify as geoheritage sites. They are all part of wider term geodiversity, but we have to identify certain sites which have a global reference and or with a substantial contribution to the development of geological sciences through history. So for example, I'm going to use most of the Indian examples. So as of today, we have 2 IUGS heritage sites. One is the GSSP of the Meghalayan stage in Mamlu Cave. We know there's the stalagmite which has the record of the latest age on the Holocene epoch, which is 4,200 years from now. So this is one of the designated in the first volume which we brought out, the first 100 IUGS heritage sites. And the second one is the Deccan Trap. Okay, then the geocollection is a museum collection or part of a museum collection of global importance because of its particularly high scientific, historical, or educational relevance for geological sciences. For example, I witnessed the meteorite collection of Natural History Museum, Vienna. So you have to have a relevant context when you make a proposal, that why you want to nominate this collection as a geocollection and why it should be ratified. So there's a lot of paperwork to be done, and I think India has made proposal for 2 geocollections. So these are some of the geocollections which are already ratified. So as of now, we have total 11 IUGS geocollections, and India has none. But with 2 in the pipeline, hopefully they'll be ratified. An IUGS heritage stone is an IUGS designated natural stone that has been used in significant architecture and monuments, recognized as integral aspects of human culture. Now, why do I say that this is very relevant? Although most of the people, they don't talk about heritage stones. They mostly talk about the natural sites, and they talk about museum collections. But these are equally important, the reason being that whatever is based, for example, the historical accounts, the cultural relevance is all based on the stone. The foundation is the stone, and everything is recorded in the stones. For example, if the evolution of life is recorded in stones, so is the culture of humanity is recorded in the stone, through the artifacts, through the monuments. So to give an example, Makrana marble is a IUGS heritage stone, and we all know that Taj Mahal is there, but how many of us internationally know about the Makrana marble? So this is one of the first designated IUGS heritage stone from entire Asia. So I would like to talk about the Zumaya meeting, which was held in 2022, where the first book on 100 geosites was released. And there we signed a Zumaya declaration. So this is the book which is freely downloadable. If you want to know more about the first 100 sites, we now have a volume on second 100 sites as well. So if you want to know more, you can download the book from the site. You don't have to buy the book and read about the different sites. We may be knowing many sites, but knowing 200 sites of geological importance is going to be very helpful for us as a geologist. Okay, so I forgot to tell you, during this meeting, the first 22 IUGS heritage stones were also announced. But we produced a book last year where we recorded 55 IUGS heritage stones. So this was the IUGS Zumaya declaration. The strong points for the declaration were geology and society, collaborative science, and geological heritage. So I'll give you a quick example. Geology and society, when you talk to people about geoheritage, the relevance of geoheritage, I think you connect more with the people. You connect with the masses. It's very important. If you take students to any monument and you tell them stories of the rocks, you show them the textures, I think they'll connect more. So that's the relevance. Collaborative science, there are a lot of fields involved in it. We collaborate with Archaeological Survey of India. We collaborate with historians. So it's not just confined to science stream. We have to take into account a lot of other streams, and it's a very, very interesting field when we talk about heritage stones. Geological heritage, this is all part of geological heritage, whether it's a geocollection, geoheritage site, or a heritage stone. So geological heritage, again, an excerpt from the declaration, knowledge of Earth and its history is based on places and landscapes, which I think you were talking about, that have been described and studied since the birth of the geological sciences. Some of these places have a special value. Now that special value, which we also call outstanding universal value for UNESCO, they are inspiring and extraordinary places that have contributed significantly to the development of geological sciences. They represent the memory of the Earth and are part of the natural heritage that we must in equal parts value, manage, and use and conserve. Now here is that preservation, conservation part. If you don't know about your heritage, you are not going to talk about its preservation, you are not going to talk about its conservation. So the first step is to let people know about it. It is very important. And the second, the resolve which we took, the IUGS adopts the mission to acknowledge geological heritage of the highest scientific importance, collaboration between all international initiatives involved with geoheritage and geodiversity can lead to their further appreciation. For example, IUGS collaborates with UNESCO. So there's a collaboration. And on regional basis, we have global geopark networks. So they also collaborate. So they are all region-based. So there has to be a collaboration between all these bodies, further appreciation to their sustainable use as educational resources. If you don't have samples of some stones, you can take them to the monuments and show them the textures and the rocks. Why not? Let them experience that. Make a nice geotourism tour for the common masses, for the students, and they can serve as live laboratories. And most importantly, to their preservation for the good of society, for future generation, and for the planet's well-being. So if you make people aware, then only they will talk about preserving them, and then that's good for your planet also. So this is the book which I'm talking about. There are two books released. One is the second 100 geological sites, and the first 55 IUGS heritage stones. So this was last year during the International Geological Congress held in Busan. Again, this book is freely downloadable. You can read about the second list of 100 geological sites. And this book is also freely downloadable. So you can download the book and enjoy it. All right, so part 2. I will now talk about, I spoke about the IUGS initiative, so mostly about the UNESCO. UNESCO runs 2 initiatives. One is the World Heritage Site, and the other is UGGPs. We call it UNESCO Global Geoparks. So UNESCO Global Geoparks and UNESCO World Heritage Natural Sites fulfilling the criteria 8, which is very pertinent or important for a geologist. So this criteria has been used mostly to talk about the geological processes which shape shapes up the landscapes and why they are important. So this is dedicated geological criteria, I would say. And whereas UNESCO Global Geopark, it's a collaborative endeavor which started in 2015. And it has taken over very well now. A lot of geologists are involved in evaluating UGGPs now. And these I already discussed. So let's quickly go through what's a UNESCO Global Geopark, because there's much more than just a scientific value when we talk about a UNESCO Global Geopark. It involves the community, it involves the livelihood, it involves the education of the people, it involves the indigenous people as such. So it's not just about sciences, whereas in IUGS we only talk about the science behind any site, any stone, any collection. So UNESCO Global Geoparks are single unified geographical areas where sites and landscapes of international geological significance are managed with a holistic concept of protection, education, and sustainable development. So the key is sustainable development of the area. You cannot debar the people from that area, entering that area. I was reviewing one of the papers on the Shaligram, which is found in the Nepal, Himalayan part. Now the people, the indigenous people, they are not allowed to enter that area because they say they spoil the site. But what an irony, they belong to that place, but they are not allowed to enter that area. It is a confined area now. So we have to take into account that the people are not displaced from that area. Their bottom-up approach of combining conservation with sustainable development while involving local communities is becoming increasingly popular. At present, there are 229 UNESCO Global Geoparks in 50 countries. India is not part of it. We were discussing that we need a bill, but even if the bill is in place, are we ready to make a proposal? Have we studied about the local communities? Have we talked about the sustainable development of that area? Have we identified any area? So these are the criteria for designating any UNESCO Global Geopark. I would not like to read it, but they all talk about broadly the things which I spoke. And I will give you one example of the Basque Coast, which I visited in 2022, 2021. It's a beautifully preserved flysch section, which is a continuity of 1,500 meters. And you have two GSSPs in this. One is the Thanasian and other one is Salindinian. So these are the two GSSPs, that is Global Stratotype Section and Points. So that's the scientific value, and it's a fishing town where they have involved their community into a lot of tourism. So they are developing this geotourism very beautifully. And it's not like this is a geopark area. They have put the placards everywhere describing the scientific value and the touristic value. And it's very nicely recorded. You just put on the headphones and walk through and you will cover the entire area. So there has to be a plan in place before we send any proposal. So you can see sustaining local communities, a lot of things are there. Now, I was talking about this global geopark network, which is very important. Snigdha, are we part of any global geopark network as of now?
If we have to enter into that network, we have to get into the aspiring stage.
Okay, so as of now, we are not. Because most of the countries, these are all regional, like for the European nations. It was basically started in Europe only. And then it spread over to other places. We have an Asian Global Geopark network, but I think we are not part of it because when you associate with them, it's much easier. These are like arms of UNESCO Global Geoparks, extended arms. So then it becomes much easier for you to identify, propose any geopark. So Global Geopark Network, as I said, it works in close association with its regional counterparts, such as European Geoparks Network, Asia Pacific Geopark Network. So these are all the members. All right, so what are the UNESCO criteria for designating? So geopark is over now, and I'm now talking about the World Heritage Sites. So if you look at this criteria 8, to be outstanding examples representing major stages of Earth's history, including the record of life, significant ongoing geological processes in the development of landforms, or significant geomorphic or physiographic features. So lately, in the tentative list, GSI has took a lead, and they have 7 proposals listed. And at the end of my presentation, I'll request Snigdha to brief us about those 7 sites, which are listed also on the UNESCO site in September 2025. So I'm glad that we have come forward and at least using criteria 8, which we don't have as of now. China has a lot of sites designated based on criteria 8. But specifically, like UNESCO has 3 different types of World Heritage Sites. One is the cultural site, the other is the natural, and the third one is a mixed site, which is having both the elements of cultural as well as natural. So we have a lot of natural sites and cultural sites, but we don't have any site, natural site based on criteria 8. So these 7 sites will be the new sites based on criteria 8 and which needs a geologist input. So kudos to GSI that they have proposed these 7 sites. All right. So I just gave a reference of one of the papers because when we talk about geodiversity, geoheritage, geoconservation, we try to interchange these terms, which is not good because we should be very clear about what is geodiversity, what is geoheritage, what is a geocollection. If you start mixing these terminologies, then you can't work. You have to be very clear when the concepts are concerned. So if anyone is in the audience is interested to know more about it, so it's a very nicely written paper. I'm not boasting, but the concepts will become clear at least. So India's status vis-a-vis global geoparks, geoheritage designations, UGGPs, none. UNESCO World Heritage, I have rectified this list this afternoon after talking to Snigdha, 7 listed in September 2025, and it's in the tentative list. It is not a designated site as of now, but it's in the tentative list. It might get designated someday. Then IUGS heritage sites, we have 2, as I already said, Mamlu, Meghalayan stage, and the other is Deccan, and 2 more in the pipeline. Proposals are submitted. Whereas IUGS heritage stones, we have 7, which are already designated, and IUGS collections, 2 proposals are again made through GSI. So I will quickly run through these 9 slides where the designated ones are shown. So this is GSSP of the Meghalayan, the Deccan Traps, and the stones, the Jaisalmer, Western Ghats laterite, Alwar quartzite, Himachal slate, Indian charnocite, Makrana marble, Deccan basalt. So these 9 are already IUGS designated sites and stones. So what's India's potential? I think we have a huge potential. There is no dearth of sites or geocollections or stones. We are very well endowed with different stones. So on the Geological Survey of India's website, I could see they have listed 90 sites as geotourism, geoheritage sites, and further categorized on the basis of geotourism, fossil park, rock monuments. When I clicked at the rock monuments, I could see they have identified the characteristic, for example, the columella basalt. And if I further click columella basalt, I'll open up another page, which I will show you, geological marble, other monuments. So they have categorized it. So if I open columella basalt, it talks about St. Mary's columella basalt. Now I have little problem with this website, that it has to be very attractive. If you look at a place like this, with a photo like this, I don't think anybody would consider it as a geotourism site. Look at this picture, which is on our IUGS website. Look at the morphology. The columella basalts are so clearly seen. Look at this Giant's Causeway. I have been to this place. Look at the columns displayed. And look at the seat on which I'm sitting. They are like different seats. So how beautiful. So one has to be very powerful when we connect with the people and what we portray. It's very important. So that is my request, that the website should be updated with very interesting pictures and accounts. Okay, so regarding the UNESCO sites, we have 44 World Heritage Sites. 36 are cultural. We outnumber the natural sites, and I am interested in the cultural sites because most of the cultural sites are stone-made. They have the foundations in stones. There can be intangible ones also, but most are based on stones. I'll show you how. And then the 7 natural one are all based on biodiversity, most of them. So if we add these 7, which are proposed by Geological Survey of India, it will be a very nice beginning, because India has a lot of potential where you saw 90 sites put on the map. So we can talk about those sites also. And one is a mixed site, so I'm not talking about it. And we have only designated 7 stones. So we have a scope of designating around, say, 20 more stones, which are used in UNESCO monuments. So this is a small stone kaleidoscope which I have made. The 7 stones are already designated. Now the 3 which are in pipeline are Clozapet granite, then Condyllites, and the Vindhyan sandstone. So these 3 are in pipeline, and hopefully we'll get them soon. So you can see it covers the whole of India. All right, so part 3, IUGS, which is very close to my heart, and I work in this field only. This is heritage stones. So a brief account of the number of stones which have been ratified as of now. There are 55, which includes 24 sedimentary, 17 metamorphic, and 14 igneous. And if you look at the distribution of these stones, the picture is very lopsided, because you have 38 stones from Europe. Compared to the Asian or African continents, it's way too much. So we have to gear up and propose more stones, and we are inviting like the countries which are underrepresented. So that was our IGCP project, where we wanted countries like Africa, South America should come forward and propose their stones. All right, so these are the listed stones. You can just go through the list quickly. And if you look at India, so these 7 stones, which I already showed, and most of the stones are from Europe. All right, this is on the world map. You can see the clustering in Europe. So further categorization, which are the ones which fall in sedimentary rocks, the ones in metamorphic, and the ones in igneous. After designation, what? So is it symbolic that we have designated a stone? After that, what? What's the next step? How is it helping us? Collaboration, conservation, restoration, education, outreach. Now, I would like to talk about outreach more. Outreach and a little about education, because when we talk about collaboration, yes, we are collaborating. Conservation, yes, that's very important. We need to conserve it. Restoration, because I'm not showing pictures where you'll be surprised. In some of my initial talks, I always portrayed the restoration in Qutub complex. You will be surprised. Instead of the red sandstone, they have just applied the mortar, and it looks so ugly to you. So one should also collaborate with the restorers, that what rock has to be used for restoration. You just cannot, and for that you need to know the attributes of the rock. So this is all scientific part of our subcommission, where we talk about the physical properties, the microscopic characteristics, everything is included when we make a proposal. All right, so I am getting emails from people from different walks of life. For example, this is an email from an artist from Poland. She's preparing pigments from rocks, which are used in cave paintings, which are used in normal paintings. And I was so surprised, how can you make a pigment for painting from a rock? This was a new concept for me also. And in fact, I was talking with Benita, one of our colleagues from Germany, Christine. She was vice president with IUGS also. When she looked at my status, she said, I want to use some of your slides, so I'll show you how the pigments are made. So she writes to me that she would like to collaborate with us and would like to propose some of the old cave materials which can be designated by Heritage Stone Subcommission. So I would have never expected an email from an artist. So this is a beautiful outreach. So look at how we are preparing the pigments. I also attended one course where I prepared a lot of pigments from rocks, and then I could use it for painting. Another, from a geotourist guide. This lady is working with University College of London, and she makes excellent tours of the cities where she shows the different rock types utilized in London, and she runs the page, London Pavement Geology. Just browse it. You'll be surprised. Ruth Sidal is her name, and this is a beautiful paper. She recently wrote to me that for the Vindhyan sandstone, because she's reviewing my paper, She said it has been used in our Canary Wharf. There are around 20 countries and 50 different stones used in this contemporary square. Can you imagine? But are we documenting our stones? That is important. Think of Jaipur. Jaipur is a UNESCO heritage city. It got its tag, I think, last year. Abhi UNESCO heritage city hai. And Jantar Mantar got it in, I think, 2010. But nowhere in the dossier the rock has been mentioned. Sadly, it's just the word stone written. So can't we identify the rocks used in Jaipur? So a geologist can do that. So this is just an idea. I'm getting an email from a doctor. He wants to open up an eye hospital in Gurugram. He's asking, we read your article on Jaisalmer limestone and are intrigued by whether Jaisalmer limestone is good as a... So see the outreach. How many people, are we not connecting with the society now? Look at another email. These are two Swiss architects. They wanted to know more about the quarries from where the Jaisalmer is coming. So they wrote to me. So a lot of people write like this. I'm just giving you a few examples of outreach. So outreach can be in this manner also. Then food for thought. This is one of our voting members. And he sent an email to me. He's from Mexico. And when we published our Laterite paper, Western Ghats Laterite paper, he said one of his students in the classroom, while he was teaching about heritage stones, noticed that it is very similar to the scoria, which has been used in their heritage. And we are almost like done with a paper where we are comparing both the stones. Although they are different, one is a sedimentary material and other is almost an igneous one, but they have very identical textures. This is Bomb Basilica, Goa, and this is from Mexico. Then, as an outreach activity, we have tried to bring out books. There are 12 books in a series where natural stone and world heritage. This was a first attempt where we not only talk about the historical accounts, we have identified all the rocks used in the monuments. For example, I took up this project in 2017 and finished it by 2020, where I have covered 5 monuments, UNESCO monuments, 3 from Agra and 2 from Delhi. So we have documented all the rock types used in these monuments. All right. So there's this application prepared by our group in Torino University, where when you just open up this application and you walk along the city, you will get to know which stone has been used in which part. How interesting. So this is all promoting geotourism. So how are you going to create interest? So this is my endeavor. Me and my university colleagues, we made this beautiful IUGS heritage stone calendar. Since we have heritage stones from 24 different countries, so we picked up 1 stone from each country. So these are 24 heritage stones from 24 countries. This is another. This is for the Indian audience. We have picked up 12 interesting stones. So again, an outreach activity where we have tried to connect the stone with the monument so that it seeps in well across masses. All right, I will give this calendar to you. I will give a calendar to you. Then we have a colleague in Berlin. She has built these mobile panels. And this is also part of geocollections. All the 55 IUGS heritage stones are on these panels, so they can be moved to any city for exhibition. So why can't we make a mobile geocollection on heritage stones or whatever we want to exhibit? All right, so this is the concept, display on mobile panels, Museum for Natural History in Berlin, and we all contributed, like I gave 7 Indian stones to her. So I'm not boasting about all this. Why I am putting these 2 pictures is to let you know that people are very much interested to know about stones. I was invited for a public lecture where people wanted to know about laterite. And I was invited to Indian Statistical Institute where people wanted to know about stone. The lady who heard me at Indian Academy of Sciences invited me to ISI Kolkata to know more about the stones, how they can be used. So this can be anyone, but the thing is, what I'm trying to emphasize is that people do want to know if we have a way of telling stories to them. All right, so how heritage stones helps in understanding history and cultures? I'll just run through some of the images which are self-explanatory and then I will wind up. Okay, look at this. It's a very powerful image carved in sandstone. What do you interpret out of this image? Another image, again sandstone, a very old carved sandstone. Look at this. Now, the story of Delhi post 10th century is so interesting, and we have tried to relate it with quartzite, the quartzite ridge which is running through it. So there was a very nice book published, Fractured Forest, Quartzite City. How many of you have heard about this? So just read it. A sprawling megacity of nearly 20 million people, Delhi has forgotten its ecological history, a key part of which is the ridge, often referred to as Delhi's green lung. At various points, Delhi has been a crucial hub of politics, warfare, trade, and religious expansion on regional and global levels. Placing Delhi's environment at the front and center of its unique history, the book tells the tale of the ridge, which resonates far beyond the boundaries of India's capital. The ridge offers a crucial vantage point, which is very important for viewing these historical and geographical interconnection. Its trees can't be separated from the stones below. So you cannot talk about the life without stones. I always say it's a tagline, geodiversity, biodiversity is all dependent on geodiversity. But you have to have an approach how you are going to communicate it. Then again, this book, and then post 10th century, the story of Delhi, the first city, second city, all the cities used this quartzite, which was very much sustainable because it was locally sourced. So how the city of Delhi looks now. So these are the ridge, Yamuna River, but now how Delhi has expanded. And that's why we are not able to suffice to the needs of the city. When it was confined within the ridge and the river, it was doing very well. Way forward, okay. So why? Just, okay, 2 minutes and I'll wind up. This is the last part, way forward. Now this way forward, if you look at the 6 criteria of UNESCO, all the criteria talk about human creative genius, or people talk about the human values, the architecture, the type of building, the traditions, but nowhere the stone has been mentioned. So we are in talks with ICOMOS and IUCN. The proposal is almost ready. It's a very difficult task to make UNESCO include stone as one of the criterion, but we are doing it and hopefully we'll be successful. So I gave few examples, the Globigerina limestone from Malta, Deccan basalt, and the Bath stone from UK. You will see they all are based on stone. But the criteria which have been used, the megalithic temples of Malta, it's made in Globigerina stone, but nowhere the stone has been accounted. It's only the architecture, the freestone standing structure, nowhere the stone has been mentioned. So we want that stone should be included as one of the criteria. So that's the way forward. Look at the city of Bath, all made in stone, but nowhere the stone has been mentioned. Look at Ajanta Ellora, our UNESCO caves, but nowhere the stone has been mentioned explicitly. It only talks about the architecture, the Jain temples, the Buddhist temples, the caves, the Shiva, everything, but nothing about the stone. And we are coming up with this special volume in geoheritage, heritage stones as the foundations for UNESCO-listed cultural sites. If you can propose any stone which has been used in a UNESCO site, you are most welcome, and the call is open until June 30, 2026. That will be very nice because I told you we have 37 cultural sites. Thank you very much. And there's a little quiz, just a minute. People from Kolkata must be recognizing this ITC Royal Bengal. It recently got constructed in 2020, like renovated or whatever. I was surprised when I went to Greece this time in June. The marble which has been used is Volakas marble. It's a Greek marble. So see the beauty. We are getting the stone from Greece to build our hotels. And there's another hotel in Jaipur, which is also made from Volakas marble. So it also enriches our knowledge on the stones used. So everything has to be documented. Thank you very much, and I'm open for any query you have.
Thank you. We can take one or two questions.
Well, it was a very comprehensive review, and if you have any query and if you are reluctant to ask now, or if you want to propose anything, you can please contact me. I would be very happy to help all of you. And anyway, Snigdha is doing very good work, yeah. And would you like to add something on the 7?
I think I have a slot at the end of it.
All right, all right, all right. Thank you so much.
Otherwise, the next keynote is waiting.
Thank you, Professor Kaur, for that beautifully articulated talk. Your perspectives illuminate how stone, both as a geological material and as a cultural medium, anchors the identity of World Heritage sites across the continents. So we now move on to our second keynote lecture. I'm delighted to introduce Dr. Binita Fatiyal, Senior Scientist at the Birbal Sahni Institute of Paleosciences, Lucknow. Dr. Fatiyal is a pioneering quaternary scientist whose work spans paleoclimate reconstruction, neotectonics, landscape evolution, and Mars analog studies. She established and heads the Paleomagnetism Laboratory at BSIP, a national facility, and has carried out extensive field research across Trans-Himalaya, Tethyan Himalaya, and the Third Desert. And her scientific footprint extends from Antarctic and Arctic expedition to foundational research in high-altitude quaternary basins. She has more than 95 publications, a DSc, and leadership roles in national committees, scientific societies. And she has shaped both research and geoscience outreach, especially through her work with the Association of Quaternary Researchers. In 2023, she presented India's successful bid to host the INQUA 2027, a landmark achievement placing India on the global map of quaternary sciences. So Dr. Fatiyal will be speaking on preserving the geological legacy of Himalaya, the challenges and opportunities. Please welcome Dr. Binita Fatiyal.
Thank you, thank you. Thank you for the good words. Honorable chairperson and co-chair, both my friends, and all the participants sitting here. Till my presentation opens, I would like to congratulate GSI for their 175 years and this milestone, and I'm thankful to the organizing committee that has invited me to witness this memorable occasion. And this is not just a milestone, but as in the morning, in the inauguration, it was said it's like generations of dedication and service to the nation, where so much of hard work has gone in to give a geological fabric to India. So I'll be talking on the preserving the geological legacy of the Himalaya. I think I'll be good with the collar. May I le lo? Better? Yeah, I think I'll be better talking with this. So what I am going to talk is about the Himalaya, and one word is missing here is quaternary, so it's more of quaternary. We know Himalaya as a young fold mountain belt, some holding records of 50 million years in its valleys, in its no, can I hold it? आ रही है आवाज़ ना सबको सुनाई दे रहा, not enough people, not a big hall. So as I said, that every valley, every drainage basin of the Himalaya, of this fantastic mountain chain, has a record of tectonics, of evolution, of climate, name it, and you have a record there. And not only the Himalaya in India, as Dr. Gurmeet said, there are so many potential geoheritage sites across the breadth and length of the country. Yet, when we look at the UNESCO Global Geopark, India is not, there's still a gap there. So it is time to reflect that if, Alps can get a status, if the geopark in Hong Kong can get a status, so why not Himalaya with its beautiful, rich geological history of evolution and tectonics, as I just said. If the Badlands of Aras can get the global geopark status, and the Murang Jambi of Indonesia and the Fujian province, the cultural monasteries can get, then why not our Badlands of Lamayuru in Ladakh? The Momolu, which Dr. Gurmeet was talking about, which has the stratotype here in India, like the stratotype is in the Birbal Sahni Institute of Paleosciences, it's housed there. And we have several cultural heritage, like the monasteries in the Janskar and the Ladakh region. So all this can get global status. It's not that India is lacking in any scientific value, or it does not have any geological uniqueness, or it does not have any cultural depth, but still what is needed now from us is that to elevate all these things to the world, map. So I'll be taking you to Jammu Kashmir and Ladakh. So these both are union territories, as you know, and they are top tourist locations, and they have a huge floating population and a big and a great geotourism potential. Here, I'm only talking about the Quaternary, which is the most recent and ongoing period in the Earth's history. And whatever geosites you'll see, they are a treasure trove of information and can prove very, very helpful in understanding climate change, hydroclimate, ecology, mountain geomorphology, etc. So let's delve into it. When I say quaternary, it is the sediment on the Earth's surface which is not lithified. Some of it is, which is like early quaternary Pleistocene, but it's last 2.6 million years in the Earth's history. So itself, it has several natural threats. Like in Jammu Kashmir and the Ladakh Himalaya, because it is in the mountain chain, so it is susceptible to neotectonic activities. We see profound examples there. Then the location of these places is such that it is affected by the westerly also and the Indian summer monsoon also. Again, the sediment is very susceptible. So a combined effect of this endogenic and exogenic processes here in these sediments, it results in seismic tremors, earthquakes, landslides, gulfs, and make the quaternary sediments all the more susceptible for loss. And if you see the erosion rates, it's like about 0.1 millimeter per year in the northern rain shadow region, while in the monsoon-fed southern region, it's about 2 millimeters per year. So lots of erosion also. These are beautiful places as far as geology is concerned. Ladakh, it's a marvel for a geologist. It's a treat for everybody, where the rocks of the entire, you have the Ladakh batholith along the Indus-Switch zone, you have the Karakoram batholith, you have sedimentary rocks, Tethan sedimentary rocks, you have the metamorphic rocks. In Spongtang, you have the ultrabasic rocks, you have the ophiolites, so there is an array of geological rocks there. So the geology is unique, the location is unique, the climate is unique, and the sediment diversity is also seen. You have aeolian sediments in form of dunes and sand rams. You have paleolake deposits. You have permafrost. You have glacial deposits also, and fluviolacustrine. There is also ecological diversity that is seen in the frozen lakes, in the hot springs, in the saline lakes. So Ladakh is like full of diversity. And when cultural history is seen, that it was a subroute, both Ladakh and Kashmir was subroute of the trade route that existed between the East Asia and Europe. So, it is a place worth considering for a geoheritage site. And as I work in the lake sediments for paleoclimatic records, so lakes, you all know that they are very good indicators of climate variability. They are very sensitive recorders of the environment, and they are also vulnerable to human activities, and they can record it. So there are several lakes in Ladakh, like the Pangong So, the Somorari, the Sokar, which are big lakes. There are several small lakes, and then in the scenario of this global warming, several pro-glacial lakes are coming on the Ladakh range and the other ranges also. I will take your attention to this buff-colored facie that is exposed here. It is more of, layers of clay, sand, and mud. And this is the Indus-Sucha zone. This is the Indus River. These are the Tethan-Himalayan sediments. And towards the north, this side is the Ladakh batholith. So along the Indus-Sucha zone, I'll just give you examples. Take you in a traverse from Spituk. It's a place 4 kilometers downstream of Leh, which is the main town in Ladakh. And you see the amount of sediments that there is. So these are the paleo lake sediments. This is Spituk, this is Gupuk, several all along the river, telling us that there was a big lake there in the valley once upon a time. And what is the date? And you see, when we look at the dates, they are 17,000, 15,000, 10,000, 3,000, basically after the post-LGM and more in the Holocene. So these records are from, just very recent past. Our group did a lot of work in these lakes, recording them for several proxies like sediment texture, mineral magnetism, total carbon and isotopes, paleofacies, diatoms, and also the alkenes, the biomarkers. And we could give a story of what is there in the climatic history of Ladakh right from 14,000 years to the present. Yeah, so we could delineate all the major events, minor events, what is happening. Ladakh is getting greener and all. So just to say that the research is not finished, because these records have beautiful, fossils and subfossils in them. There are coprolites which can tell you about the, ancient vegetation. There are beautiful petroglyphs in the boulders on the which are covered with the desert varnish. There are caves, cave paintings, and lots of work more is remaining on the environmental and ecological aspects. So when you put all the work here, which people, different groups from different institutes have done in moraines, in paleolakes, in sand ramps, terraces, and morphometric also, you see there is a lot of gap in the entire Indus Valley. This is just Indus Valley. We have the Shyok Valley, we have the Nubra Valley, we have Tangze, so Ladakh is big. Now coming to Kashmir. Kashmir also is the same. Gad Firdaus Ruhe Zaminast, Haminasto, Haminasto, Haminasto. So we know that it's saying, Yadi Prithvi pe swarg, kahin swarg hai, to yahi hai, yahi hai, yahi hai. And really, it is a swarg. Swarg for heaven for us quaternary geologists who can see the entire Pleistocene till today. The entire sediments are there. So the Kashmir Valley, it hosted once, the Pir Panjal range towards the south, the Janskar Thrust, and in between there was a big lake, big when I say it's 5,000 square kilometers. And today we see what is Kashmir sitting on is the remnant of that lake, which we call the Karewa sediments, which are divided into upper, lower, and middle. I won't go into the chronology, but they are more than 1,000 to 1,200 meters thick sediments, and they have such a beautiful record hidden in them, yet to be revealed. This Karewa is not only a sequence, but it has lots of faunal and floral elements in it. And because I said the time period is so important, because this 1200 to 750,000 years is the mid-Pleistocene transition time. At this time in the Earth's history, we have records. This record is from a Marine Corps isotopic record. Here, the Earth's climate was not in cyclicity with the solar cycles. Something different was happening. So we don't know. And in the terrestrial realm, only Kareva is there in the whole world that can we can study it and give some results. So this is a beautiful site. And then, because I've been working for the last 2.5 decades in Ladakh and nearly 5 years now in Kashmir, my work is totally different. It's paleoclimate and neotectonics. But we did see and mark some fluvial lacustry, geothermal caves, aeolian and petroglyph sites in both the places. And this was the criteria that the importance of those sites, whether it's scientific, archaeological, cultural, historical, or potential of geotourism. And then I'll just, we also wrote a paper in GeoHeritage, it's in 2021, where we listed these sites. I'll just take you to a few examples. So the first site, so you see the Indus River again the Tethan Himalayan sediments on your right and boulders on your left with beautiful marks, which are prehistoric, or we can say the Mesolithic or the Paleolithic people chose this site to stay because water was there and they could hunt animals. So this is so beautiful. In the petroglyphs, the rock art is still preserved, and you see that naturally it's getting degraded because it's the desert varnish and it's being chipped because of the high altitude and physical weathering and so on. That we cannot help. But what to do for this? That it's become a dumping site of, this is Stakna. Stakna monastery was being built and this became a dumping site. So many of the boulders are inside this dump. So this, all this made us think that what can we do? Then this is Dr. Gurmeet just talked about the natural colors in the caves. This is a cave at Sispol. This is a lucky cave because it got a German project and they built a pillar because the roof was collapsing. But what about these several caves in Rumse and Gaya villages, which are huge caves, and they are all getting collapsed. They aren't even documented, they aren't even recorded. And some caves which are near the villages, they are used as a storage purpose. Then when you come to the lacustrine sites, so this is the lacustrine sediment. This is dated to 10,700 to 3,000. It is at Spituk, and you can see there is a car wash over it. Yeah, and just above this section lies this beautiful, the debate hasn't even finished whether it is a seismite or whether it is a feature formed by cryoturbidation. And there is a JCB here, which I'm very sure that next time you go to Ladakh, you are not seeing this. I've seen this site with Dr. Snigdha long back in 2019. And again, this is near Kargil, a lake sediment of 40,000 years ago, but again, there's a construction site. There are several in Kashmir, Burzam, Dilpur, Parigaon, Palar, so I don't want to confuse you with your names, and several in Ladakh, which really are under threat because of intensive mining, land modification, and ongoing sand extraction, construction, and the tourism pressure also. And similarly, Lamayuru, which is the badland topography that I was just talking about, it has a beautiful paleo shorelines there. You can see that the lake was here once upon a time. So that once upon a time is 40,000 years to 24,000 years. And similarly, the hot springs, the springs of Kashmir, the Puga. So here what is happening? There is absence of maintenance. The people just go, tourists just go make reels there. You can touch the lingam also, which is very, very sacred here. And there is a lack of conservation framework. And it's not only one site. You have Chumathang and Panamik hot springs also, which are under threat. So, there are natural threats. We cannot deny that part because being a mountain chain, there have to be natural threats. And even the prediction here, the linear prediction model shows that it shows a positive anomaly that Ladakh would be having more rains in the coming years. So we can't do anything about this. But what about these anthropogenic threats, which are urbanization, road building, construction, infrastructure development, sand mining, and so on. So can we do something about it, or can we, because this is a result of neglect in policies, unregulated tourism. You see here, this is the Ladakh tourism, and you see the blue one is the international tourism here. And international tourism is right since the 60s that were coming. But a boom in the domestic tourism after 2004. Then the population, the census after 2011 we don't have, but I'm sure this graph goes like this because there is so much of population in these areas. Then climate change, I've already said that there are retreating glaciers, permafrost degradation is seen. You must have read many papers on that. Geo-vandalism and going on, and quarrying and degradation. So what can be done? There's a short video that makes me very sad also. Oh, will it not play? I don't know. Okay, but it was showing that how the entire quaternary deposit is being mined. This is one of the pictures that I really like, and here you can see a snow leopard chasing these antlers. This is on one of the rocks in the Tangze monastery, which is on en route to Pangong Tso, which is a very big lake. Huh? कोई बात नहीं yeah, so this petroglyph or this rock art is also in their flags there. And now see this, they are whitening the road, and this comes on the I don't know what's happened to this. We did talk to the local people and told them about. And the local people know about it because this particular, it's called the Tangze Chase. And Tangze Chase is in their flags also. So we really need to protect such things. A bulldozer cannot just come and, take everything away. In the morning, I was talking to Dr. Gurmeet about this site. It is in Kashmir, Pampore member, where Dr. Rakesh Chandra and his students were there last week in the field. And if you see this portion, it's a fossilized tusk of an elephant. Yeah, and they wrote to the district commissioner, a committee was formed, and Rakesh had been sending messages to the entire geological fraternity that to impress upon the respective authority of GSI to take up the matter of the UT of J&K and to declare some type sections of the Kareva. So they are rich in fossils also, and we need to preserve them. There are challenges, and there is a way forward also. We can bridge policy, we'll have to bridge the policy practice gaps. We'll have to manage the competing interests because being border areas, defense is necessary, tourism is also necessary being a hill station, and we have to protect the local livelihoods also. And then there is an urgency to document all these sites before everything goes away. So there are certain geo-conservation strategies. So there should be good policies and governance, like inclusion of national geoheritage registers. So if these sites could be registered in there. And then Gurmeet has already talked about the community-based approaches in which sustainable geotourism should come as a tool where the community also benefits from it. We cannot we cannot say the community has to be devoid from the place which they are living in. So they have to be benefited from that. Then research and collaboration, we all research together and collaborate together. And this is very, very important. And it would be nice if GSI, with universities and NGOs and local government can formulate some geoheritage tales and school and university engagements so we can protect these sites also. And scientific involvement is always there. We need to, detailed inventories have to be prepared, and risk assessment and vulnerability mapping and long-term monitoring of these, some of these sites at least. So we did a podcast a few weeks ago. It will be nice if you could, in Spotify, it's Inqua India. It's Echoes Beneath the Valley, the story of the Kariva sediments. And the second is the quaternary story of the third pole, the Ladakh chapter. We did it as a pre-activity of Inqua 2027 that we are going to host. So, there are several geopark proposals, like the Hemis Geopark, the Changthang, the Shambling, the Konma, the Guryul Valley Fossil Geopark. There are proposals, but the quaternary heritage we do not talk about anywhere. So I conclude by saying that we need to safeguard our quaternary geoheritage, which is a priceless record of the Earth's history, and Jammu and Kashmir and Ladakh, they both have untapped potential, geoheritage potential, which is under threat. Rapid construction, mining, agriculture, urbanization, industrialization, they are eroding these sites, and there is an urgency of protection, and we need to come up with local action plans also, and a sustainable community engagement has to be worked out. And maybe, like Dr. Gurmeet also said, maybe we can adopt this geo-biodiversity concept to integrate the geological, the biological, the diversity of rocks, the fossils, soils, where we can talk about science in toto. So maybe that would also help in connecting different disciplines together. I would like to say, while introducing, it is said that India won the bid in 2023, and in 2027 we are hosting this big conference known as Inqua, and it would be in Lucknow from 20th January to 3rd February. The theme is quaternary science as societal service, and it will be very nice if we can, come up with some of these quaternary heritage sites and have a discussion there, or declare something big in that Congress. We still have a year to talk and enter into a dialogue. With this, I thank you, and as a General Secretary of Inqua 2027, I invite all of you to Lucknow. Please, that will be there. Thank you.
Thank you very much, Dr. Vinita. It was wonderful listening to some of the sites I have also visited, so I could connect with this instantly. So we will talk about it. There are many things you have proposed. There are certain things we definitely can try to implement. We will discuss about this later.
Thank you. Thank you.
Thank you, Dr. Fatiyal, for this profound, engaging, and very interesting lecture. We'll now move forward to the next lecture by Prashant Tukaram Ilamar and Pradap Jagan R.
This one is going up now.
Yes, yes. You need that thing?
No.
I request to Sri Lanka, we are running behind schedule, so if you could cut down a few minutes from your talk.
Okay. Very good evening to chair, co-chair, and dear participants. Topic of my presentation is the geological assessment of Mukteshwar Temple or caves in the reservoir area of Shahpur Kandi Dam project, district Pathankot, Punjab. As you can see, these are some of the caves in the sandstone of Shiwalik group of rocks. So I will, before going into the presentation, I will brief about the first Shahpur Kandi Dam project also, because first one should know the Shahpur Kandi Dam project and its reservoir capacity. Then only we will proceed to this assessment of Mukteshwar Temple or caves. This is the location map of Shahpur Kandi Dam project. This is one of the multi-purpose river valley project in the by state Punjab government in the border of Punjab and Jammu and Kashmir. So this is the This is the layout plan of Shahpur-Kandi Dam project. If I talk about this project, this is the 55-meter high dam, concrete gravity dam, will generate the installed capacity of around 200 plus megawatt of electricity. You can see this is the Shahpur-Kandi Dam project, proposed Shahpur-Kandi Dam project, and this is the Shahpur-Kandi Dam project, just upstream of the Madhavpur barrage going towards J&K. Shahpur-Kandi Dam project has the two surface powerhouse on the left bank of the river. You can see this is one of the surface powerhouse which is located 3 kilometer downstream from the project on the left bank of the river through open head channel. And second one is the 6 kilometer downstream from the proposed barrage. That is this one of 80 megawatt each project. You can see this is the Shahpur-Kandi Dam project, and this is the upstream 11 kilometer upstream. This is the Ranjit Sagar Dam project. And if you can see, this is the Mukteshwar Mahadev Mandir. These are located in the reservoir of the Shahpur-Kandi Dam project, and if this reservoir will be filled up, that is impounding will be taken place, then the 2 caves out of total number of caves are there, total 4 caves are there, but during the full reservoir level, that is 404.5, that 2 caves will be submerged during the full reservoir level. So our main motive or main objective was that to protect that caves from the full reservoir level. You can see this is the when the full reservoir level will be there at 404.5. This is the contour of the 404.5, and this is the Mukteshwar temple located just at 401.5 meter elevation. So what we have carried out? What we did, we have carried out the detailed geological mapping of this cave area on 1:500 scale with the help of total station. And these caves, as you can see from the geological map, these caves are exposed the Shivalik group of rocks comprising alternate bands of sandstone and siltstone. And you can see the general strike is north 50 west to north 80 west, and deep varies from 65 degree to 85 degree towards the downstream side. And this is the direction of the river, Ravi river. You can see from the geological map also the sandstone bands, which are in yellow in color, are the thickly bedded and broad at the base and tapering at the top. See, these are the cave. This is the cave number 1. Sorry, this is the cave number 1. This is the cave number 2. These two caves are located at 401.5 meter elevation, and our full reservoir level is the 404.5. So these two caves, that was the challenge, to protect these two caves from the full reservoir level. The sandstone bands, as you can see, these are the very competent, massive and fine to coarse grain. But these mudstone bands, which are very fragile in nature, very weak in rock mass condition, that is, we have carried out the rock mass condition in the field also. That rock mass condition is sandstone is very good to very good to good, but in mudstone it was very poor to nil. So UCS also we have carried out, that is because all these are the rock mass parameters are needed for the design engineers to protect these caves from the full reservoir level. Because one need to measure, one of the major challenge to the project authority, that to protect these caves and to create the some kind of wall or some kind of protection wall, that is called a guide wall also, to protect this from the submergence. While carrying out the mapping, it was found that the seepage was also occurred between the sandstone and the
mudstone band. The contact of the sandstone and mudstone, you can see that it was showing the interformational, at the contact between sandstone and siltstone, the interformational conglomerate was also there, and it is a very sharp contact. You can see this is at the full reservoir level, and these 1 and 2 number of caves will be going to submerge. We have prepared the 2 different geological sections across the cave number 1 and cave number 2. The geological section at cave number 1 was measured for a length of 102 meter, and it was seen that the cave number 1 is located at the 7 meter height above the river bed level and 3 meter below the proposed FRL. And cave number 2, it was measured for a length of 147 meter. At the center of the cave number 2, the cave is located 10 meter height from the river bed level, but 1 meter below the FRL. So in both the cases, cave number 1 and cave number 2 will going to submerge. So main aim was that to create the RCC protection wall, and some of the measures we have suggested, some of the geological inputs we have given to the design engineers, so that the sentiments of the local people and the local government could not be waste. So that care we have taken care. So we have given the detailed geological inputs to the design engineers, and the factor of safety has been calculated for the deepest excavation of 8 meter depth along this section to assess the slope stability for the slope 1-in-1. And we have suggested the concrete protection wall, that is RCC, having slope covered with 0.3 meter to 0.5 meter, 3 grouted boulder pitching along with RCC frame. This is the RCC frame. From elevation 396 meter, that is from elevation 396 meter, this is the elevation 396 meter, up to 406.05 meter. That is above the 1.5 meter from the above FRL. Over the compacted earth fill material, as I have told you that the deep of the rock is 65 to 70 degree meter, 70 meter down, dipping towards the downstream. So we will not get any foundation rock to create the foundation for the RCC wall. So that is the main issue that we have proposed the project authority that this RCC concrete protection wall should be embedded in the compacted earth fill material, which can be from there, which can be erected. The berm, benching of suitable dimension, adequate drainage network, and contour draining of the seasonal nalas, installation of drainage filters, these are the standard suggestions which we have given to the project authority, and which was also suggested in the design drawings. And these all the suggestions were taken care while finalizing these structures. This is all I have told already. Thank you, ma'am.
Thank you very much, Srinagar. This was really very site-specific and a very new kind of approach, I would say, to protect the geoheritage. So it's a new vista, I think. Yeah.
And the Engineering Geology Division, GSI Chandigarh, has given this type of suggestion, and the recommendations was rightly followed by the project authority. These are the post-remedial features also.
So if we have any quick question, we can take that. Yeah.
If you said that the water level may be there, but you will protect that cave with that RCC. So then, okay, yeah, this you said. Then how much, like, do you think it will stay long? Like, I don't know whether with the water force and pressure, won't it be unstable at some point of time?
No, that is why, ma'am, these what we are talking about, these design engineers, we have given all the design, like this is the RCC, कहते हैं 52 जो ग्रेड जो सीमेंट होता है, that we have taken care during the construction of that RCC. Whatever the fluctuation will be there in the reservoir level, that will be taken care. Again, also 0.3 meter thick grouted boulder packing. So whatever the reservoir, whatever the water level will be there, it won't be seepage into the cave area or that gufa area.
That's very brilliant. Thank you.
Thank you.
So our final presentation was by Deepika Saire and their team. Presentation. ये नहीं है ना, ये वाला है। अभी ठीक है। नहीं बस अच्छा 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 ठीक है।
No, I don't need it. Good evening, everyone. I am Deepika Saire, and I'm a researcher from Wildlife Institute of India. And the presentation is on the topic Geoheritage Assessment and World Heritage Potential of the Beda Ghat-Lameta Ghat Landscape in Narmada Valley. My co-authors are Sohail Ahmed sir, Bhumesh sir, Sabruchi Sarkar, Sir Gautam Talukdar. So this study is a part of the project Preparation of Nomination Dossier for Beda Ghat-Lameta Ghat in Narmada Valley, Jabalpur, Madhya Pradesh. And this project is basically funded by Madhya Pradesh Tourism Board. Before actually going on to the main topic, that is the OUV of my site, I would first like to give a quick overview of what exactly is a World Heritage Site. And it's an area or a landmark that is recognized by UNESCO, and it should have OUV, that is Outstanding Universal Value. Wildlife Institute of India is currently preparing 2 nomination dossiers. One is for the Beda Ghat-Lameta Ghat landscape, and the other is Satpura Tiger Reserve. This is the process. First, a site gets into tentative list, then a nomination dossier is prepared. It is then submitted to UNESCO, and then evaluated by ICOMOS for cultural site and IUCN for natural site. And then finally, it gets to the decision of the World Heritage Committee. Gurmeet ma'am has actually explained it really beautifully, these aspects, but I'll just quickly give an overview. So World Heritage Sites are of 3 types: cultural sites, natural sites, and mixed sites. OUV's Outstanding Universal Value, which I would say, it is something that it is not only nationally important, but it is important for the whole humanity, even for the future generation, and we need to preserve it. It stands on 3 important pillars. It should have one of the selection criteria. So UNESCO has 10 criteria in which a site gets nominated as a World Heritage Site. It should have integrity and authenticity, and a very important part is protection and management. Cultural sites lies in the criteria from criteria 1 to criteria 6. It should represent human creativity, history, and culture. Natural sites, which is important for us for this presentation. So UNESCO says that a site cannot only be nominated on the basis of the 7th criteria, as beauty is very subjective. It should be supplemented by other criteria as well. For my site, criteria 8 is very important: outstanding example of Earth's history and geological processes. Criteria 9 is ecological and biological processes, and 10 is in situ conservation of biodiversity. In India, we have only one site which is on the mixed criteria, that is the Kanchenjunga National Park in Sikkim. For me, the guiding document for this nomination dossier and my study was the UNESCO's operational guidelines. And we have done extensive literature review followed by field surveys. From 2021 to 2025, I would like to emphasize that Sohail sir from GSI Jabalpur division and Sarkar sir from GSI Bhopal, they conducted various field surveys for us to actually identify the OUVs and then validate it. This is my site, Beda Ghat, Lameta Ghat. It is located in Narmada Valley, Jabalpur, and this was the first site to be nominated under criteria 8 from India. And it came into tentative list in the year 2021. And there is a proposed geopark, and this would actually be India's first geological park in the Lameta village. The nominated criteria for my site is criteria 7, spectacular natural beauty, and criteria 8, which is the geological criteria. This is the boundary map of Beda Ghat, Lameta Ghat in Narmada Valley. Now, we have actually proposed this boundary based on the Beda Ghat development plan and with the consultation of experts from CMO Beda Ghat, MPTB, NVDA, and others. These are the OUVs of my site. I would like to mention one thing, that we have currently submitted the nomination dossier for Beda Ghat, Lameta Ghat. The OUVs of Beda Ghat, Lameta Ghat, which is the main criteria 7, exceptional natural beauty. So we can see there serene Narmada flowing, Dhuadhar Falls, Marble Canyon. It has been used by various film directors to shoot their movies as well. Dunki movie is the very recent one. For me, criteria 8 is very important. So it recognizes 4 different natural elements relevant to geological and geomorphological science. First is major stages of Earth's history, including the record of life, ongoing geological processes, geomorphic and physiographic features. Dingwall et al. 2005 has actually proposed 13 themes on the basis of which we can actually categorize a site to be a geological heritage site. And for Beda Ghat, Lameta Ghat, we have got tectonic and structural features, stratigraphic sites, fossil sites, fluvial. This is the geology of Beda Ghat, Lameta Ghat. It has got a record of the history of around 2,000 billion years old, from Paleoproterozoic Mahakoshal group to the very recent Quaternary alluvium deposits. And the locality where we get all these rock types or features are mentioned in the table. The marble that we get here is dolomitic marble, and it has been sculpted by the Narmada River, where the river first calmly flows and then plunges into a 30-meter deep gorge, where it flows ruggedly and in a very narrow gorge. The second site is the Ghugra waterfall. It's in the same Beda Ghat, Lameta Ghat landscape. We get to see unconformity between Lameta, which belongs to the late Cretaceous, and Mahakoshal, which belongs to Precambrian. We also get ignimbrite rocks here. It is also a very important fossil site. We get sauropod hatchery here, belonging to Maastrichtian age. Species is Megalolithos jabalpurensis, and the depositional environment is fluvial lacustrine. It is a very important site, and this study is also published in Srivastav et al. 2015, wherein we get the sauropod egg nest as well as the crocodile hatchery, mesocrocodiles from the family Dryosauridae. There is a point, one of the site, which we call Swargdwari, that means gateway to heaven, So there we get eroded dolerite dike, which actually intruded into the marble rocks. In the dolerite rocks, we get onion peel weathering. It is very visible, you can go and see, and elephant skin weathering in the marble rocks. Not only this, the site has got a history of river piracy. The Narmada river has actually changed its course. This is the Paleo channel at Saraswati Ghat. We can see the hanging V-shaped valleys, triangular facets, and I would say here we get quaternary alluvium deposits, the oldest being the Baneta Formation, which is buff-colored, overlain by Hridaypur Formation, which is khaki-colored, and then we also get channel-fill deposits. We have conducted some LiDAR surveys here. This is the LiDAR-derived images. We can see that how Narmada River has actually changed its course. First, it was flowing in the right direction, and now it flows in the left direction along the canyon. The site also has cultural significance. It has got Chauset Yogini temple, which belongs to 7th century and is built by Kalchuri dynasty. And here the pilgrims also practice Narmada Parikrama. So the pilgrimage route actually takes 3 years, 3 months, and 13 days to actually circumambulate the Narmada River. Now it has got a bit faster. In conclusion, I would like to say the designation of this site as a UNESCO site is very important, as this is the first site from India to get nominated under criteria 8. And till now, India doesn't have any site which has been nominated or inscribed under criteria 8. The underrepresentation, the gap is there. My site demonstrates exceptional geological, geomorphological, and cultural value. The natural beauty aligns with UNESCO World Heritage Criteria 7 and 8. We need to strengthen stakeholder engagement, which we are already doing. We are conducting various capacity building workshops, creating awareness among the masses, and we regularly, in collaboration with the GSI Jabalpur division, we conduct various workshops to create awareness among students, among officials of the government. This approach supports India's commitment towards UNESCO World Heritage Convention and aligns with UNESCO United Nations Sustainable Development Goals. These are the peoples I would like to acknowledge. Specifically, I would like to acknowledge GSI for giving me the chance to present my research here. Director, Dean and Registrar WI, my PI Dr. Gautam Talukdar, and specifically Sohail Ahmed sir and Sabruchi Sarkar sir for helping me in identifying the OUVs in and out whenever I needed them. Thank you so much.
Thank you, Dr. Deepika. I think we are just 5 minutes past the scheduled time, so we can have 1 or 2 quick questions before we conclude.
I just have a question. In the quaternary of the Narmada, even the skull, human skull has been found.
Yeah.
So why is that not your own?
So that doesn't come under my boundary. I think it's in Hatnora. Yeah, it's in Hatnora. Kilometers, yeah. You're most welcome.
Thank you very much. So, I don't know whether she has to stay anything or if you don't have, so we can take it over from here. It has been really a very thought-provoking session because we have relieved certain things that we usually are like not acknowledging this much. But yes, so
which I'm missing, that we should have had more people for the session. And the presentations, I really enjoyed the presentation made by Vinita, and I would suggest her to make a proposal and submit it for designation to UNESCO World Heritage Site. If not a geopark, at least you can document all the features and put it under category 8 and try to see if it gets accepted in the tentative list. And same goes for, I think that is already in the tentative list since 2021. She mentioned something about it. What is it? Yeah, she already mentioned. So that's a good initiative, and hopefully it will materialize. And I was very happy when I interacted with Snigdha in the afternoon that GSI has already made 7 proposals based on criteria 7, which she said is not sufficient. You have to substantiate it with some stronger criteria, with criteria 8 in the case of the 7 proposals. So I would personally like to know more about how she managed to do that, and what was the teamwork like about all the 7 sites.
In that case, it becomes my presentation. No, really like to know. Okay, so I'll just say a couple of things here. But first of all, I'd like to congratulate each one of you, because I think it was 4 different spotlights giving light to different directions of geoheritage studies. And I know you also have in the SIP one Geoheritage Study Center. I don't know whether it's functional. Okay. So let me put it this way. We have been discussing about international recognitions of the geoheritage sites. Everybody know that what is geoheritage site like. And there are international designations. When she has also shown one site. Why is it just for ornamentation that we are giving a tag to the geoheritage site? It's not. I'll give you one example from this recent, I mean 1 week or so, 1 weeks back. So as she has already mentioned, 7 geoheritage sites we got enlisted in the World Heritage tentative list in the month of August. So it was a 1.5 years journey, I would say. We started, and all of us were newbies, I would say, because I took over charge in 2023 December, and all these activities suddenly started happening from January onwards, January 2024 onwards. And then we started submitting these proposals. And as there are different criteria, like age is one of them. So when we had submitted those documents, there were not many times of back and forth movement, because we were happy, okay, we are geologists, we will submit some geoscientific proposals. No, when you have to submit, because I think the WII person is also there, so they are category 2 center for UNESCO World Heritage Site. What most of the states, when they submit a proposal to UNESCO World Heritage Center, usually there is a component of collaboration with WII, because they give a lot of input. Similarly, when there is a cultural component added to the site, there are different other advisors who put in inputs on the cultural aspect. So we were like, standing in a pool of water, not knowing how to move, because we were not specialists in the biological aspect or the cultural aspect. But thanks to my team, I said nothing doing. Whatever it is, you go through the literature, study and fill in. So they really worked hard, and it was a composite kind of thing. When it was told to us that tentative list is only a 2-page document, you just fill in and submit. It is a matter of 15 days. And then, how you start these things and how it happens. So the basic idea was, then it goes to ASI. So Archaeological Survey is basically the identified nodal organization for this purpose, when it goes to World Heritage. And so these are 2 arms of UNESCO. So one is this World Heritage, where ASR is the nodal organization, and she has spoken about Geopark, for which GSI is the nodal organization. So this notification was issued in the month of June 2024, I guess, yes. And we constituted, because with this mindset that yes, India now needs to move towards establishing Geopark. So Ministry of Mines and GSI together, we formed this National Committee for Geopark. So it is chaired by our Secretary Mines, co-chaired by DGGSI and the member secretary. So we had the first meeting, and the decision was that let us start in a humble way. So 2 to 3 geopark areas should be selected, and then because it is a long process. Now, if we go through this arm of World Heritage, after getting enlisted in the tentative list, it takes again 5 years, and there are 2 bodies, ICOMOS and IUCN. There is a rigorous scrutiny. There will be a lot of things you have to, because once it is World Heritage, the site needs to be pristine. You know, if we temper with some or other element of the site, the designation doesn't come true. Whereas Geopark is a little bit of relaxed kind of thing where everything's right. I mean, yes, development is also there. Like Dr. Vinita was showing us, yeah, I have seen that section in Spituk and those things. But now some construction has happened. So those losing those sites. So we need to conserve those sites. So at least the moment some proposal is there, then we can take it up for conservation. From the presentation of Sri Lankar, I was thinking that it is a very methodical way of geoconservation. So when we paid a visit to Greece for this UNESCO intensive training on Geopark, we saw that there are, there is a fossil park, a fossil place that was fossil park. So there for each and every fossil preservation, they have come up with a different plan. Sometimes we put a shade, like you are showing the petroglyphs. Yeah, there should be shade put up. Sometimes, if the site is getting affected by water, cut a different nala through which the water will flow out. So these are the different ideas. So similarly, what he has shown, this is very, very nice, and I strongly recommend you put it up in a paper. People need to know. So these are the few things, and as you have also mentioned, so we started from the basic point. We felt there is a need to systematically improve upon this geoheritage studies. So the first thing that we did was geoheritage inventory, the national register. And that number is now not limited to 90. On occasion of this International Geodiversity Day, 2 more geoheritage sites have been added. One is Gurbil Ravine from J&K, and the other one is particular granite feature. So how did this got enlisted, or we do this? Now we have taken up a process. We have put up a template in it is available in our portal, and we are promoting citizen science. Citizen science, and that's, I will repeat what our DGGSI has told in one of our last meeting during the International Geodiversity Day celebration. He said, let's work together, let's walk together. So that is the spirit. So keeping that in mind, we have tried to promote citizen science, and the Bhuvirasat app. I would request whosoever is interested here, please download this app. Bhuvirasat app was launched on the foundation day of GSI's 175 years celebration on 4th March by the Honorable Minister of Mines. So this app allows any person to log in and then fill in certain information. Since it is for general public, we have not made it exhaustive, but if you go to the template, it is exhaustive. You have to fill in those parameters, and those proposals are taken up. It is communicated to us. We have constituted one Geoheritage Assessment Committee. This committee evaluates this proposal. Once that is channels. In most of the RTI grievance applications regarding these geoheritage sites, whenever we get the reference of GSI, the GSI had identified. Now see, when these 7 geoheritage sites were enlisted in World Heritage Site, 2 weeks back there was a paper. Suddenly Andhra Pradesh government set up a special task force for conservation, geoconservation of Eramati Dibbal. That is another badland. It's a dune, red sand dune. So these are very important sites. Now this kind of sensitization through the channels of government and non-government, through grassroots level, whatever it may be, it has to have a holistic approach. And the moment we are serious, people will also become serious. So right now the approach we are taking, although the geoparks have to be simply called as a bottom-up approach, but looking at the scenario in our country, because there is a lot of sensitization that is required, so we are going from top to bottom and then bottom to top. It's kind of a cycle that we are trying to go to. Yeah, so this is in nutshell. It has been wonderful to be present here. Although we had 4 presentations, but I think those were cream. Some of the cream things from the geoheritage studies we have really got to know. I can keep on saying many things, but time is short and it has been a long day. So I thank one and all for being present here and hope to see more number of such promising studies, because it's the thought process. The way he has looked at Mukteshwar temple, I don't think he has not thought about it from the geoheritage angle earlier, right? So it's something like that. You have to look at things from the lenses of geoheritage conservation, and it doesn't need separate degrees. We all are geoscientists, so we can pull in our efforts, resources, and all. Having said this, let's again work together and walk together. And this geopark proposals, we will. There is a we are also updating our website. So from one generation to next generation, it is under transition. So all these things that we were telling, it's my commitment. We will get it done. So thank you. We should work together and thank you.
Thank you, ma'am. So with this, we bring the session Guardians of Time Geoheritage Preservation to a close. My sincere thanks to our chair, co-chair, keynote speakers, and all presenters, and our audience for participation. Thank you, ma'am, for your thought-provoking words. And may I now request our DDG, Sri LMS Mora sir, to please present our keynote speakers and our chair and co-chair with a token of our appreciation. A round of applause for Dr. Kaur, please. Yes, ma'am. A round of applause for Dr. Ghatak, our chair. A round of applause for Dr. Fatiyal. Thank you, sir. Okay, with this, we formally conclude our technical derivations for the day. And I invite you all to join us in the main auditorium for a vibrant cultural program that celebrates the spirit and heritage of this land. Thank you.